fix my video issue. But we are going to start each panel session with a short introduction to the teams who are presenting each panel. We're running 8 panel sessions today, and the 8 panels cover a wide variety of project teams. The short minute introductions are going to just give a brief overview of the videos that the teams have previously prepared. Just to let you know, the teams have actually done loads of work behind the scenes. You're only getting a very, very small view of what the teams have done. It's just as a summary to remind the judges. We've got a prestigious list of judges today, which we'll tell you about later on. We're running a little bit behind, so I'll do that introduction a little later on this afternoon. We will then go into questions and answers with each team member. So think of it as an Oscars overview of each of our teams, followed by a question and answer session where our teams will get the chance to answer questions from panelists, from the people joining in, and they've also prepared questions for each other. When you come into a panel as a student, we want you to raise your hands as an attendee to be promoted into the panelists group. So if the students in the first panel can raise your hands now, then you can get promoted into our first panel. At the end of a panel, you will get taken out of that panel, and we will have the next group raise their hands to come in. So use the hand raising only for being put into a panel or taken out of a panel, okay? If you have questions, there is a Q&A option, which we will be using for monitoring questions, but the moderators for the panel sessions will be asking those, okay? So we do need to keep on time, and I am running behind. So what we want to do is to get the first panel loaded up shortly. We will then show the first videos of the first 4 teams, and then we'll jump into questions. Whilst we're just loading up that group, I did want to say I am today coming from Victor Dadele, which is where we were meant to be presenting. Obviously, I'm at home, but I'd hoped to have little versions of each of our projects that have been developed. Unfortunately, time got away from me last night, but we were happy to try and bring you a virtual Victor Dadele today. So if you can start promoting the first panel in a minute, that would be great. And then what we will do is, whilst we're showing the first set of videos for the first 4 teams, we will get the panelists in for that, and then we will kick off questions straight after that. Just to let you know about some of the people behind the scenes, we have a whole team of people behind the scenes working crazily to get things going. Is there anything that I've missed that I should have added, if somebody wants to chime in? If not, could we queue up the first video for the first 4 teams, and let's get going.
Hi everyone, we are Team AD and our project is ASCAT. It's a software tool that aims to automate the standardized sports concussion assessment test. We decided to build it to make concussion testing more accessible, improve accuracy and consistency of scores, and give trained athletic therapists more time with their patients, not assessing them. Using a Kinect camera with computer vision technology and custom-built software, we designed ASCAT to score a patient on their ability to perform movements without the need of any trained administrator. Simply using our software and the Kinect camera, patients can autonomously receive a SCAT score. And through the challenges of developing the project, we focused on developing the algorithm capable of turning a recording of a patient performing a movement into a score. And we saw limited yet promising results.
Ride-sharing presents a valuable option to combat carbon emissions, we are focused on engaging with the environmental benefits of ride-sharing, specifically the programs offered by organizations to their employees through leaderboards, point systems, and badges. The gamification will be compared to other users in a similar area zone, so users can compete with their community.
We want to choose different starting points for the people who are going to be commuting together, Toronto and Mississauga. And as you can see, the backend returned us with a route from Mississauga to pick up the person in Toronto and take them both to York University. So this is just kind of providing some insight as to the environmental impact of the trip. We're working to get the community charts and kind of have a gamification system where users be able to earn badges.
In the future, we would like to implement our platform into ride-sharing applications to allow users to become more environmentally cautious of route choices, as well as be more engaged in one's community to actively lower greenhouse gases.
Course timetables are an important part of a student's university experience, but there does exist a lot of problems with current timetables, from extreme gaps between classes all the way to technical electives conflicting with mandatory courses. Presently, our faculty uses a historical-based manual approach to schedule that includes a collection of Excel documents and a lot of interdepartmental communication and negotiation.
The main dashboard appears after the user logs in. The user can use the filter box to quickly hide or display different groupings of courses that have already had times associated with their classes. From here, the user can add new courses by using the Add New Class dialog here. I'll go ahead and add a new course right now. Once the course has been added, it will be shown in the list of courses. The course scheduler takes in courses set up under different groupings called curricula. So for software engineering, we have the complete list of courses they need to take here. Let's add that elective we just made to it as well, since we want to avoid having core courses conflict with electives. After running the scheduler, we can see that the courses have been shifted to remove any conflicts between them.
We are the Wayfinding at York team, and basically our task was to design a system to help users navigate across both the Keele and Glendon campuses, both inside and outside of the buildings on campus. York has a PDF map. It's a 2D map of a bird's eye view of campus, and it's decent for seeing where things are, but it's not really good for navigation. The biggest problem we had was with data gathering, and that's exactly what we wanted our scope to be after the pivot.
So we built a Wi-Fi Analyzer application for data collection. This is going to be an Android app that collects Wi-Fi intensity values at specific points of a building floor. So to use our application, all you have to do is enter the building name, a floor number, which is 4, and then you enter the X and the Y coordinates, which is 2 and 8, and you hit the Start Scan button. That saves the value of the Wi-Fi intensity. So on the left side of the screen, you can see how the results have been saved. It shows the X and the Y coordinates, and it shows the number of Wi-Fi intensity values that have been taken.
Okay, there we go. That's our first group of panelists. Thank you for those short videos. So I would like to open it up to our judges to start the questions. Do we have any questions from our judges? Whilst they are thinking of them, I have a quick one to each of you. So this first group of teams was our group of Agile group project groups. Using Agile project management. So my question to each of you, whilst we're getting our first panelist questions in, is what did you learn most about the Agile process through your capstone experience? I'll start with AD.
Sure. I guess you guys can hear me, right?
Yep, go for it, Sammy.
Yeah. So I guess like we kind of also talked about in the course, we did switch to more of a waterfall approach midway through. So should we just talk about the waterfall one? Because we did kind of skip into that kind of approach. Go
for it.
Sure, yeah. So it was just more so, I mean, we wanted to go into an agile approach in the beginning. Again, it's mostly a software project, thinking we'd be able to reiterate, every few weeks due to typical sprints. but it became more obvious for us, especially because neither of us in the team had a lot of strong experience in Agile. And we also kind of knew exactly what the software had to be. We had an idea of how to scope it out. So we just thought, okay, maybe it's better to switch into waterfall, know exactly what we're making, make our requirements, make our features that it needs to have. And we kind of have this roadmap and this product design set. And then when we just went ahead and started developing it. But it does take a lot of time because it's a lot of overhead. So I guess that was the difference. And it seems like while we were doing the presentations throughout the semester, it does contrast a lot to how the Agile teams kind of go. It seems more free flow. I personally think I might like Agile more, but I'll let the rest of the teams talk about that.
Okay, thank you, Sami. Team I, so you are one of our cross-campus capstone teams. Would you like to tell us a bit about your experience with Agile?
Absolutely, yeah. So our team had to, first of all, face the challenge of educating everyone about Agile project management because most of us weren't familiar with it. And as we got to learn about it, what we appreciated was, given the circumstances, our team had to pivot very many times. And Agile supported that very well for us because with each iteration, we sometimes had to change our requirements completely, and it worked really well with us. So we figured that Agile project management would work best for fast-paced projects where you're getting new requirements quite regularly. And we developed a better understanding of what we want from our customer and how to accommodate them while we're already working to it.
Thank you, Team I. So thanks, Akbar. Team AB.
So running Agile basically helped us keep on track. When we practiced all the things that were Agile practices, such as stand-ups, retrospectives, we learned that they were facilitating us in our project and helping us keep on track, and also kind of helped us bond as a team and helped us manage our team better.
Thanks, Fahad. And finally, Team E.
All right, I'll go ahead with that one. What we learned as a team is that, as the previous groups have mentioned, is that the Agile method is very fluid and flexible in terms of the scope generally, and in doing so, the requirements can change, and that it allows the teams to take a different path to the final goal than they originally thought of. And that could be very useful for if your client doesn't necessarily know exactly what they want, and then that allows you to navigate through your project that way.
Okay, thank you. Do we have a question from our judges at this point, if anybody wants to chime in? Otherwise, I'll go for the next question.
Sure, I've got a question.
Thanks, Roger.
I had a question for Team AB, the timetable optimization team. So with your optimization algorithm, what were you trying to maximize or minimize when you were doing your timetables?
If you could just a reminder, Claudia's poking me inside. If you could just introduce yourself with your first and last name as you speak, that would be much appreciated as well. Thanks, Maxime.
Hi, I'm Maxime Mikhailov, and I worked on the optimization algorithm itself. And first of all, we were just, because we were writing it from scratch, first we were just trying to make it so that it schedules courses and there's no obvious conflicts, like courses happening at the same time for the same group of students. And afterwards, we started making it a bit more advanced and trying to make some basic stuff that we as students wouldn't like about our schedule, like having 3 courses in a row, or having too many courses within the same day, or having too few courses, like just 1 course in a day is not also great for people who are commuting. And yeah, nothing super complicated, but simple things like that that's what we're trying to optimize for.
Okay, next question.
Yeah, I got a question.
Thanks, Uday.
Yep. So my question's for the wayfinding team. So for your product, is there some sort of abstraction service that you provide where you can sort of just take the procedure that you've built to and then apply it to, say, different buildings within York to expand the map, or say even apply it to different universities to sort of widen the scope of your audience?
Yeah, I think that was actually sort of the whole goal of the application that we built, based on our difficulty to get data for different buildings. We decided to build an app that would help us to get data so that we could do all the navigating and stuff that we needed to do, and more than just the buildings that were readily available to us. So that's something that could easily be expanded to other universities or buildings within our own university.
Thanks, Jeff. So next question.
I got a question.
Thanks, Lucas.
So for Team I, so you mentioned that you would want to incorporate your program into like ride-sharing apps, but what would motivate a ride-sharing app to want to include your feature in their apps?
Absolutely. So that's a great question. We had to figure that out while we realized that's a value we want to add, because for many organizations, they have a sustainability goal that they have to meet, and being able to provide a service where they give their users the option to be more environmentally friendly looks better on them, first of all. And our pilot project was working with YU Ride, where they wanted to have a sustainability factor built into it, and it also helped meet York University sustainability goals. So that was our main goal towards it. It's not, again, we pivoted to this and we realized there's organizations which want to give the choice to their users to have a more sustainable option.
Thank you, Akbar. Question for the next team.
Yeah, I got a question.
Thanks, Uday.
So this one's for Team AD. So can you guys speak a little about the correlation between the assessment that your project provides versus the assessment, say, a physician would provide for the same patient?
Sure, just to clarify, by correlation, what exactly do you mean?
So say how accurate that would be given the different categories that you've split the assessment into, and are there other factors that you're taking into account, say the time spent for the patient when the assessment's being made by your project versus a physician, and what other differences or similarities would there be?
Sure. So one of the results that we did do, let's say in the sports concussion assessment test, there's a series of movements you have to do. One of them, for example, is stand on two legs with your hands on your hips and eyes closed. And that's the first algorithm we focused on. We actually compared our results to a hand scored version, and we can go into those later if you'd like. But really, it's supposed to be a very strict, and it's laid out how a physiotherapist is supposed to grade a person doing the movement. So how they, the degree to which they raise their legs, how they bend over. And that's exactly what we were trying to replicate, as well as give the same score in the same format. So they do it out of 10, we'll do it out of 10, and we'll try and count. What the physiotherapist is supposed to do is count the number of errors up until a maximum of 10. And I guess going to what you said, I mean, that can count for a lot of things. How long are you maybe out of balance? How long is one body part, bent too much? Like, when do you go back to baseline? That kind of made it more of a challenge. Again, thinking of all those corner cases, because it's not so simple as breaking this model, which is what we made, maybe like a cylinder around the person where they can't move their body outside of. but then how long is it okay to stay out of that cylinder? What if they get back, but they're not exactly where they were initially? So yeah, those are the considerations. How well does it correlate? We got some scores that were decently similar, and that's about it.
Already impressive in the current climate to have some scores. So appreciate that. Thanks, Sammy. Next question.
I have a question for all teams.
Thank you, Ryan.
So during this uncertain time, I'm wondering if having the agile methodology, do you think helped you guys with the COVID pandemic, or took away from it, and some of the advantages that you guys found choosing this methodology?
And we'll start that with AB, our timetable team.
So when the pandemic hit and everything was shut down, we found that Agile actually helped us adapt to that, because Agile was helping us adapt to situations even before the pandemic. So whenever we had exams or assignments or other deadlines upon us, Agile helped us adapt to that. We would arrange hackstones, or we would change the length of sprints to fit in the work. And when the shutdown happened, we had the Agile tools to figure out how to deal with that, how to take the meetings online, how to schedule them, and work out a way to work even within the shutdowns and work from home. That all Agile kind of streamlined that process for us. We were ready for it.
And Fahad, do you just want to say a word or two about how your hackstones worked?
So the concept of hackstone, basically, we were under a lot of pressure. We had a lot of tickets left for our capstone project, and we were trying to get to our MVP. So one of us had this idea: why don't we, instead of doing that sprint over a 2-week period on our own and trying to go there on our own, we instead assigned a day for it, and we called it Hackstone, which was a combination of hackathon and capstone. And we basically gathered in a room in the university for 8 hours straight, all the team in person. We got our food supplies, and we basically coded for 8 straight hours, debugged it, discussed it, from planning to deploying. Everything happened on the same day. And we kept doing that whenever we needed to reach some goals, whenever we needed to reach a release.
Thanks, Fahad. Perhaps the indoor-outdoor wayfinding group would like to jump in. What do you think has helped with the Agile process, maybe through the changes that your team had to go through?
Yeah, I could definitely speak to that. So a big part of our project was we actually needed to be at York to do surveying of the buildings and figure out, where things are, because navigation is a huge part of our project. So when the pandemic hit and York closed down, that kind of put a wrench in our plans. And it was the last kind of shove we needed in order to convince us that a pivot was totally necessary. And that's when we decided to pivot strictly to data gathering. And that was something that we could do in our own homes, because our data gathering, it just relies on, signals from routers nearby, and everybody has internet in their house, and so it's something that we could test at home and develop at home. And so we were able to make that switch because of Agile. If we were doing waterfall, I am not really sure what we would have done when the pandemic hit. So we're definitely thankful that we picked Agile, and it's certainly helped us.
Great, thank you. So there's probably time for one more question for everybody. If there's no urgent questions from the judges, I'm going to jump in with a question to each of you. What do you want the legacy of your project to be? So we'll start with AD on that.
Sure. Well, I think we actually laid out a pretty good step-by-step process and design of how you would go about doing and automating this sports concussion test, ASCAT, that's what it stands for. I do want and actually think it'll be really, really useful that in the coming years, there's a lot of body tracking technology coming around, actually. One of the things that recently came out is an iPad with LiDAR and body tracking. So you can imagine that'll be on future phones. And I think in the future, I think the legacy would be nice if this carries on into something everybody kind of has in their pocket, not just for concussion assessment, but body metrics and analysis in general. I think it's really important that people kind of know they're moving well, they're doing motions the right way. So I would hope that would be the legacy.
Thank you very much, Semi. Team I.
So the legacy for our project would certainly be making users aware of their carbon footprint from their commutes, and just making them realize how much of a difference just sharing a car with a person can make in the long run as an individual and as a community.
Thanks, Akbar. Team AB. So it's not Fahad jumping in. Who's going to jump in for Team AB to think about your legacy?
Sorry, I had my mic muted.
No problem. Thanks, Connor.
Yeah, I think when we started out, we had this really grand idea that we would be able to create some beautiful finished product that we could be able to not only apply to Lassonde situation, but hopefully to other faculties as well. And as a result of numerous things, it's not at that point. But I think one of the things we really appreciated, I think, about it was the idea of students proactively seeking out solutions to the issues that we experience in university. And so I think it'd be really cool to be able to pass that on to future generations, and maybe in the future another capstone team could continue taking that on, and hopefully over time it could be built into something that could be fully implemented into Lassonde's workflow. Because I just really like that idea when people start taking ownership over the issues that they see in the world, and specifically with students. I think that'd be really cool to see that going forward.
Thanks, Connor, and a shout out to wearing the t-shirt for the team. So great, thanks. And finally, Team E, indoor-outdoor wayfinding. What do you want your legacy to be from this project?
All right, I'll go ahead for that one.
Thanks,
so as was mentioned, the overall goal of the project was to perform indoor and outdoor navigation. Sadly, that's a very, very big project, and this will be passed on to future capstone teams. And the biggest problem for us was data gathering. So we hope that our app can be used for, of course, indoor positioning, but also could be used for research by TAs or professors. So we hope that the app we generate will be able to be used moving forward.
Thank you very much, Derek. And that basically concludes the panel one. Thank you all, teams AD, I, AB, and E. Round of applause for you. We will be shortly moving on to panel two. What we need to do now is make sure that all the panel two attendees have raised their hands. There's 21 of you, so that's looking hopeful. We will be moving the panel one group out of the panelist session back to attendees and moving panel two in. And I am going to hand off to James, who is the moderator for the second panel of the day. So thank you very much. You'll see me a bit later on for panel four.
Okay, thank you, Franz, and thank you, panel one, and thank you for all the staff who are making sure this is running really smoothly. We'll get started in a minute or so. And we'll begin with that video. So thank you everyone for participating today. This is going really well, which is awesome. So it's been an absolute pleasure helping to run Capstone this year. Everyone's done a really, really good job in spite of all of the road bumps along the way. There's been a lot of really good developments in a lot of the teams. All right, so as soon as that video is ready to queue up.
our work revolves around one central ethos. That is simplifying urban farming, so more people will grow food closer to where most of us live, in cities. We boiled down our questions into one real root problem to take on. This was the inconvenience and inefficiency of urban farming. Many urban farmers we met had made it their full-time job. They had taken several years and killed many a plant to hone their skills. This steep learning curve made it impossible for any collective behavioral change to occur, leaving us dependent on highly unsustainable agricultural practices. Loop is a standalone food-growing system with a modular design, meaning you can easily grow anywhere you can fit the unit into. Plants don't need soil. They sit in a growing medium inside pods that are slotted into the holes you see on Loop, much like a Keurig. Loop uses a technique called aeroponics, where the plant's roots get misted with a nutrient-rich solution, and any excess water is looped right back into the water reservoir and reused, making it highly water efficient. Loop isn't just a piece of technology, though. It's also a service. People who purchase Loop have the option to follow a subscription service where they receive a monthly delivery of the plants that they would like, already in their reusable pods.
In the current state of the world, non-renewable energy generation sources produce up to 80% of the power generated, which can contribute to significant carbon emissions. York is guilty of this too, as we get most of our power from the main grid or cogeneration, both which produce lots of carbon emissions. Our goal is to find a way to try and produce significant amounts of power while reducing carbon emissions and not having it be considered a bad investment for the university. To remedy this, our goal is to design a non-emitting microgrid for York University, which is a local energy system consisting of distributed energy sources that can interface with the main grid or operate on its own to supply power to loads while producing minimal carbon emissions. The final design that we came up with mainly consists of PV panels and lithium-ion batteries. Namely, we have a 20 megawatt solar capacity and we have 8 megawatt hours of lithium-ion batteries.
Affordable and clean energy is one of the global challenges we face today for better livelihood. Although many urban communities have high rates of electrification, this quickly diminishes when you go to off-grid rural communities.
Our team created the Solar Floaty, a low-cost solar concentrator for cogeneration of electricity and heat to address the problem of accessibility. It uses low-cost, accessible materials to magnify the irradiance of the sun 20 times onto a solar panel, resulting in more electrical output than a conventional solar panel. 2 units are able to provide someone enough electricity to power LEDs, electronics, and a cooker. The Solar Floaty can also provide space heating by recovering the heat from the solar panel, resulting in a low-cost cogen system, and can be adaptable to one's needs.
The Solar Floaty can also be implemented in various communities. Our Open Innovation Framework allows local engagement for communities to adapt this technology to their specific needs. An SDG check is also incorporated to analyze the potential effects an innovation could have with respect to the SDGs.
Our chosen project is to design and build an inflatable solar thermal collector with applications in remote regions. We related our problem to 2 of the 14 grand engineering challenges, which are providing clean water and making solar energy economically viable. Current evidence shows that 1.7 million deaths could also be avoided each year by providing access to safe drinking water, sanitation, and hygiene.
And here it is, an inflatable solar thermal concentrator. There is a reflective layer contained between transparent sheets inflated to create a concave shape. This allows it to act as a reflector, which we can use to concentrate sunlight to a focal region. This allows us to heat up water to the point of boiling, which when used with a proper distillation setup, can output clean water. We intend to build a receiver which would contain the water to be boiled. We also intended to build a third prototype which would involve pre-tensing the plastic sheets before gluing them.
Okay, thank you very much. So we had to recap 4 different projects. The first one was the urban food growing project. The second one was the non-emitting microgrid to reduce carbon emissions. And then we had 2 separate projects on developing solar energy collectors using inflatable and non-stiff materials. With that, I'd like to ask to find out if there's anybody that has any questions, either from the TAs or the judges.
I have a question for
Yes.
Team J.
Yeah, Lucas.
So you guys mentioned a subscription service. So would that be providing like the seeds already in the pod or the germinated plants? Because that has different challenges if they're germinated already.
Yeah, that's a good question. That's something that we talked about a lot. Oh, I was supposed to say my name. My name is Myers Bar, and we actually user mapped out both of the options. So if we were going to be doing just the seed in the pod, we designed like a covering that goes on top, because when seeds are in the germinating stage, they have very different needs than when a plant is fully growing. The ideal scenario that we were aiming for in our as intended design was transporting germinated seeds, because something that we found was that germinating can be kind of tricky, and if you mess up during germination, it's very hard to have like a healthy, successful plant that doesn't randomly die. Not speaking from experience, but so that was designed to be like our ideal case scenario, doing the pre-germinated ones. But if we were doing not germinated, we'd have a covering over it. So yeah.
Oh, sounds good.
That answers it.
Thank you. It's a very timely project, as many of us are starting to create gardens and that with summer approaching. I just want to remind everyone that that if you haven't done so already, please modify your username so we can see your first and last names are given and family names. Thank you. Was there another question from the panelists to either the urban food growing group, the microgrid group, or the 2 solar energy groups?
Actually, I have a question, James.
Okay.
So for the team for the urban farming, why did you guys decide with a circular structure? Did it provide any advantage over the standalone shelf structures we see in the markets nowadays?
So would the urban farming team like to field that question?
Yeah, I think both of us are speaking at the same time. Go for it. Oh, you can take it. Okay.
Probably 2 very good answers coming up.
Primarily, the circular design was chosen like just in the sense of like manufacturability was a huge aspect to it. And then also aesthetics was a huge thing. Circular just generally tends to look good. And it was also, our design is made to be scalable, so it can be stacked on like various levels. So instead of it being like the 3 feet high prototype that we made, it can be up to 6, 12 feet, as high as you need depending on your space. So circular just was a better option for all of those reasons. And then factor in audience engagement and sort of just when you bring in a circular design, you have like extra stress points and all of these extra unnecessary problems that arise with it. We found that the circular structure was just the best option.
Yeah, I was gonna add on to that and say I think there's a regulation about this as well. So especially in like regulated farms, you're not supposed to have any points where like water can stagnate and collect. And if you have like sharp corners, water can collect in those, and it's really hard to clean out. And if you have like damp areas like that where things are essentially collecting, you can have nasty little microbiomes that you don't want growing there. So that was another reason that we tried to ensure that anything that would be in contact with like the water and the nutrient solution had like those circular edges.
Okay, thank you.
Thank you. While we're talking about design for manufacturing, actually I'd like to hear from Team F. What did you learn this year? So this is one of the first of the 2 solar energy collector groups. Designing for manufacturing, how did that, what was that sort of, or how did it impact your project?
I can go if none of my other team members want to go. Okay, cool. So we actually had to put in we had a lot of challenges in terms of manufacturability. So if you looked at our design, it's basically a mylar balloon that has to keep its shape. And this is mostly done through inflation. So we have a lot of interface we have to take into account of in order to ensure that airtight seal. So for example, in our design, we had to carefully design the heat sink or like the bottom base component in order for the mylar balloon to be nicely sandwiched in to keep it airtight seal, while also being sure that each individual part of the heat sink is able to be easily manufacturable. So, and another part of this too is also the balloon itself. So we previously had a lot of round spherical designs because we were inspired by beach ball. Beach ball keeps its shape very nice, but because of its spherical shape, it's actually much harder to, have your panels and weld them together to make the balloon. So we actually pivoted to a compound parabolic shape. So this is a shape that's a lot easier to manufacture. It's basically like when you discretize the different sides. So not only are you able to have panels that you can actually weld together to make the shape that you want, but it's also a shape that's advantageous to our concentration ratio as well.
Fabulous, Teresa. Thank you. And Team G, I believe you had some interesting experiences with testing of your materials and then manufacturing. Would you like to talk about that for your solar collector project?
I think I can take it away from my team. So in terms of manufacturability, definitely there was a big gap between actually modeling our system and then producing it. Because obviously when you try to inflate something, it's kind of hard to control how it decides to inflate. And there's a lot more things you have to consider, like the interfaces. So a lot of investigation went into how to join the materials. And then when it actually goes to the actual connection of the materials, it's not as straightforward as, okay, we just got to throw some glue in between and slam them together and just inflate it. There was a very iterative process that we had to undergo to understand the behavior of the gap between the design and the prototyping. And I think that's probably was our biggest challenge. I think for us, definitely it was because we decided on a circular design. One of the biggest challenges was sealing, because it's not really 2 or 3 different continuous paths. It's one continuous path. So if you kind of screw it up, there's going to be a small gap, there's going to be a small leak, and it's really difficult to deal with.
Yeah, I'd like to add on to that point. Also, on top of material compatibility, as Usman said, like the gluing the stuff together, we also did experience quite some wrinkles. As you might have seen in the video, there was 2 prototypes. First prototype had quite some wrinkles, and then we, let's try something else. Let's try a different second prototype. Hopefully we can reduce the wrinkles. So yeah, material compatibility and like the wrinkage was like one of 2 big issues of the manufacturing.
It's really nice to hear young people worry about wrinkles. So we have three teams that had to worry a lot about manufacturing and physical designs. We also have another team, the non-emitting microgrid project, that had I think it'd be fair to say a more long-term view of project development. And so a very different experience with respect to Capstone. And so I'd like to hear from the microgrid group as to how you view your project with a more long-term view for project development.
Yeah, so one thing about our project is it was kind of one step along the way to a eventual microgrid at York University. So we had a group last year that kind of started one part of the project, and then we kind of used the findings that they had to kind of pivot into our own direction. So with our project, there was no like, as you mentioned, like manufacturing as other groups had. Everything was kind of on paper, like a lot of brainstorming, a lot of thought into it. And then eventually what we worked into was testing the actual viability of our plans and seeing if it would be, if it would even make sense for York University to pursue it. So just through our results and through our testing, that's basically where all of our kind of learning took place and all of our significant progress on the project took place. So at the end, we have something that maybe next year's group can add on to, and eventually it'll grow into something down the line.
Yeah, and I'm pretty sure you've got a better appreciation for how difficult it is to work on energy infrastructure as well, and why it sometimes takes a long time for power plants and energy systems to be brought online.
Yeah, exactly, definitely. And you see it too, like in like OPG or Hydro One projects, just for the province's energy, like if you hear about a project, it'll be like 10 years before you see the actual like start date of the actual like manufacturing or whatever it may be. So yeah, we definitely appreciate that a lot more now.
Yeah, absolutely. Thank you. All right. Were there other panelists who would like to ask questions?
Hey, James, I got one question for the solar teams. So you guys had completely different inflatable balloon designs. How did you guys figure out the optimal geometry that you guys wanted? Was it based on like what kind of efficiency you were aiming for, or what were those constraints, and how did you guys finalize on your geometry?
How about we break up the answers into both teams? We'll start this time with, let's see, how about we start with Team G? Sean and Usman.
I can take that answer if you want. So in terms of optimal geometries, they were kind of inspired by existing solutions. So a lot of existing solutions use kind of like a dish tiles geometry, or like I'm not sure what you call it, the half cylinder. So pretty much in terms of our design, it was pretty much inspired from that, where we were just trying to replicate that geometry because we know in real world applications it works quite effectively. And that was pretty much the main process. We didn't do too much research outside other possible geometries because we found through some research papers and various investigation that that would be the ideal geometry for our case.
Yeah, to add on to that, the geometry, right? So like it has to be like concave, right? So if I was to concave, like curved surface, right? That way, like the light, the way it works is like incident rays will like reflect towards like a focal point, or like yeah, focal point. And this focal point, it can either be like a line focus or a point focus. But like Professor Cooper, he showed us a design that was built by a graduate student, just to like give us a bit of a background, like for the start of the project. And it was like a cylinder, right? And it was like a curved surface. It helps concentrate the light rays to like a line focus. But he wanted something like a different configuration, just to like, just to express a bit of our creativity. But like he wanted something more of like a point focus, because that'll give like more, potentially more energy output.
Excellent. And Teresa and Team F.
I'll take the question for our group. So similar to what the other group said, we kind of based our design off existing concentrating mirrors, but those are expensive and made out of solid materials. So we started off by adopting a point focus instead of a line focus, which is currently in practice. So like parabolic troughs, for example, conduct a line focus on like a pipe, for example, to heat up water. So we went with a point focus, which was a spherical design, in order to increase the concentration ratio onto one point, which would be our solar cell, for example. We had to iterate the design. It almost turned into a rapid prototyping exercise, kind of, because through testing, we learned that it was quite difficult to manufacture that, and we went to a cylindrical design. And then with the help of Dr. Cooper, we found this compound parabolic concentrator design, which we modified a little bit to allow for a greater acceptance angle at the top, which allows for just less accurate tracking, and that can be done manually. And basically, we just optimized this design so that we would have the highest concentration ratio to allow for the solar cell to generate as much power as possible for the lowest cost.
Yeah, and if I can add on just quickly, so just adding on to the tracking part. So one of the biggest costs to a solar concentrating system is the tracking, because you're basically tracking the sun in order to get the maximum, the amount of radiation. So being able to have a wider acceptance angle drastically picked our geometry size, as well as in terms of our design itself, because we were a cogeneration project, we had to consider both electrical and heating outputs. And so that's very difficult to do if we have, say, the solar cell and the heating components on the top. So the great thing about our geometry and design was that it's very heavy on the base. So it's much easier to pivot and a lot easier to impact, and overall just provides less expensive solutions to things like counterweights and whatnot. So yeah.
Thank you.
Thank you.
Did any of the panelists have other questions they'd like to ask?
Sorry, James, before we go off of me, just for curiosity, I got one more question. Because I could see the CAD exploded view for the parabolic design, I could see that that design was just maximizing the output of one solar cell, if I'm not wrong. So how would this scale based on demand? Like, is this like a simulation of a scaled down version of a solar panel that you guys had, or it's just going to be individual solar cells with these parabolic structures on them?
So I can take that if no one else wants to. Okay, yes, so it is a solar cell, and the reason for this is because the purpose of the proof of prototype is to just show that you can have some kind of electrical output. Usually when you have a solar panel, there's multiple cells like in series, but because of like the different junctions or like the way a solar panel is made, it's much more expensive. So the way we envision scaling it up, if not using a panel by the end of it, like we made our design such that you can string like either 4 units with 1 solar cell in series, or 1 unit can have a base of 4 solar cells in series. So I hope that answers your question.
Yeah, sure.
I have a question.
Yes.
I have a question. Okay.
Oh, we'll start with Zuitai.
Yeah.
PEO.
Thank you. Hi. So this question is for Team J for the urban farming. I see that on your team, there are people from other faculties that on your team, and I think Lassonde has been doing this since last year. Do you think the people from the other faculties contributed or helped with your design solutions on how to maximize the output of your urban farming solution?
During the design phase, there was a lot of conversation. Sorry, my name's Hanya Ali. But yeah, during the design phase, we had a lot of conversation about how to make sure that we're like solving for the right problem. In particular, we went back to the problem statement quite a lot, and that's where a lot of our like ENVS and media students came in, because they brought in a lot of really good perspectives regarding the users that would be involved and the environmental impact that would have. And instead of just having the engineering perspective, we were able to bring in the perspectives of people that represent the world as in a more realistic depiction, as opposed to just like in a small closed loop. So I think for sure that they helped a lot in the ideation and like the making sure that the product that we're creating and the work that we were doing was focused around the right end goal consistently.
Yeah, if I can just jump on, I think it's also kind of important to recognize that even when we look at different disciplines and faculties, it's almost like a mosaic. Like even when I look at 2 engineering students, they don't have the same perspective or the same expertise per se. So when we had ENVS students and media students, they brought in like not just perspective from their degrees, but also just like so much perspective from like different things that they've done as hobbies and other stuff like that. So I think one of the C4 members that we had, who like sadly ended up having to drop the course, she had worked in agriculture a lot, so she was able to point us in the right direction about things that like knowing the very like technical scientific details of what conditions plants need to thrive and survive, which we had known nothing about. Like I'm like a serial plant killer. So things like that helped us really like be pointed in the right direction. But at the end of the day, I think it also helped being like complete beginners and having that perspective as well, because that's who we're designing for. Like the purpose of our project is to make urban farming convenient for people that have absolutely no clue how to do it. So like we kind of had to go in and break things so that when we make things for other people, they don't break in the same way that we experience it. So I think it was kind of flipping back and forth between those experts and non-expert perspectives.
Perfect. Thank you. Sorry, I just want to make sure, because I'm being cognizant of time. Rajiv had a question as well.
Yes, I have a couple of questions for Team F. Did you look at the maximum cost to build your panel?
So this is the solar floaty team?
Yeah.
Sorry, can you repeat your question? Maximum.
What is the cost that you came up with, material cost?
Sure. Actually, Sandra, do you want to answer this or shall I?
Sure. So we did two cost analysis. So for one, we just compared the material cost to the instantaneous watts produced. And that turned out to be like $1.80 per watt, which is less than a conventional solar panel, but it could of course decrease. But there was a lot of questionable aspects in terms of materials, because we were looking at sourcing them from other sources, perhaps in bulk. And another method we looked at was doing the levelized cost of electricity and levelized cost of heat. And that's primarily because our, just doing the material cost compared to a solar cell doesn't really give you the usefulness in terms of heat, because we don't only provide electricity, we provide heating abilities. So in order to show that we did a comparative method that is usually done for cogen, which is the LCOE and LCOH. And with that, we got costs that were about $0.013 per watt for the electricity and about $0.08 per watt for the heat, which was very comparable to the methods that are in Chile, which was the area that we choose to focus on.
So did you do any field testing?
No, unfortunately, we could not do that due to the situations.
Fair enough.
A lot of the testing was scheduled around the time that the university shut down for most students. Yeah. Rajiv, did you have a quick question? Because we're going to have to,
During your design, did you look at energy storage aspect of it as well? So you're collecting solar, you're generating solar energy. Did you also consider storage?
I'll answer that.
Sure.
We made that outside of our project. So just basically the output of the concentrator itself was the system boundary.
Yeah.
Okay.
So you're just looking at instantaneous.
Good job.
Okay. Well, hopefully we'll have some time for follow-up afterwards. I think we could probably continue asking questions for a while. All four of these projects were super interesting. It was a pleasure working with all of you over the course of the year and seeing how things developed. At this point, we're moving on to the panel number 3. So if people who are supposed to be panelists in panel number 3, if they could use the raise hand function, please, so that we can add you to the panel group. That'd be fantastic. Thank you, everyone. Thank you once again, all of you, for the work that you did this year, for sharing your experiences with us. I had lots of other questions I wanted to ask, but we've unfortunately run out of time right now, so we'll have to follow up another time. Thank you very much once again. We're going to hand off to Hossam and the 4 next teams.
Thank you, James. Hello, everyone. So we are almost going to start in 2 minutes to start our 3rd panel, as soon as we make sure that all the students are already moved to panelists and they are ready to go. And meanwhile, we're going to wait for the video, which we can start the video in a minute or so. And then we have 4 teams. We have team V and W are working on the microfarming water chiller, and we have team T and U working on the maritime naval generator. And I think we can roll the video now and take a quick look.
The purpose of this video is to detail the final project documentation of the water chiller designed by Team V for its client, Kenobi Technologies. Kenobi is an indoor farming company that specializes in the automation of indoor farming to try and reduce the cost of shipping produce from far areas and bring the produce to more local. The task that our group faced and attempted to complete was the design and assembly of a chiller that could be functional at their company site in hopes of commercializing it for use in those local areas. From the critical design review report and discussions with the client, the team had originally decided on the following 4 requirements as the goal of the design. 1. The cooling capacity of the chiller must be 1,760 watts. 2. The chiller must be modular such that
to allow multiple chillers to be attached to it in parallel. 3. The chiller's GWP must be lower than the value listed in the requirements. And 4. The system must be capable of heat reclamation. Our team successfully incorporated each of these 4 design requirements into our final assembly. The technology in our system is not novel. It uses the basic concept of facilitating heat exchange from water to a refrigerant in a closed-loop HVAC cycle. However, the novelty of our design is that it operates on a smaller scale as other commercially available, with a size of 1,760 watts cooling capacity, where the smallest commercially available unit that we could easily find is over 55,000 watts.
Water chillers are devices used to lower temperature of water. It is used in many industries and in a variety of applications. They are frequently used in farming and food industry, as well as manufacturing industry. This cooling device can cool products and machinery to the desired temperature. This can be done by removing heat from water and rejecting it to the surrounding environment using a refrigeration cycle, which comprises of multiple parts. Canopy Technologies has a vision of bringing small-scale water chillers for indoor farming into urban communities. So for our project, we are making a water chiller as per specification of Canopy Technology and our stakeholders.
Our system relies on a refrigeration cycle to activate the processes of evaporation, compression, expansion, and condensing, in addition to automating the path of water through a water reservoir.
An air conditioning unit works on the same principles as a water chiller, and it also implements almost all of its components. So the team decided to acquire one for a moderate price and reuse most of its components. We actually use 4. The condenser, the compressor, the expansion valve, and the condenser fan, which are shown in the picture on the right.
What's novel about design? So what's new and innovative about our design? Basically, our design is environmentally friendly, scalable, compatible, and programmable.
Our goal at Tidal Energies is to harvest the clean energy generated by waves into useful energy used in various applications. We have been presented with the problem of designing a linear generator that aids in converting these low-frequency waves that generate a lot of force into more useful energy without resorting to rotary generators. The design will be providing for marine applications as the priority, with the goal of being environmentally sustainable through the usage of clean, freely available energy from ocean tides.
Our team created a preliminary selected design, and we created a sketch of this along with a list of some of its key features. So the first feature is that it's fully floating, meaning that it won't be anchored to the ground, to the ocean floor, making this a more portable device than what is currently on the market. The second attribute is that it'll be a point absorber with a spring. The third would be that it uses a permanent magnet to convert the mechanical motion into electricity, and the buck boost converter will be used in the energy and power conversion process, along with a LabVIEW code to output our results.
The conversion of wave energy into usable energy is extremely complex due to the hydrodynamic processes present as the waves propagate to the shore. In essence, the conversion to electrical power is subject to hugely varying energy fluxes. Two main sought-after features of a maritime linear generator is its ability to withstand rigorous environmental conditions, as well as having a high efficiency. Our main objective is to deliver a linear generator that is more than 20% efficient. With a budget of $1,000 and a time limit of 8 months, we were able to produce a linear generator that harvests wave energy by absorbing it with a float and incorporating a magnet to convert it into electrical energy. Our system has exceeded the 20% efficiency desired by the end user, Pinoplo Inc., and is also mobile and easy to use. We hope that our design helps further advance the current technology and increases the use of renewable energy.
Thanks all the students and thanks for all the videos. I'm just going to start the floor for questions, if there is any question from the judges.
I've got a question.
Yes, sir.
Okay. So we have Farouk, Akash, and Rajiv. So Akash, you are on the picture on the screen. So go ahead.
Okay. My question was for the design with the springs in it for converting tidal energy to useful energy. So spring is a good, I guess, mechanism to take small oscillations, absorb small oscillations. Did you guys consider any other mechanisms? And it's a two-part question. The second one was, how is it insulated from the bottom to prevent the water from coming up or coming inside and destroying the permanent magnets and coils and stuff?
So I guess this team can go to both team T and U. So if team T want to start answering the question.
Sure, I'll start off. My name is Emily Martino. So for the first question where you were asking about the use of the springs, another method that we considered using at the very beginning was using like magnets to absorb that potential energy and convert it on the back and forth motion. But we decided that that would be a little bit too difficult to implement because we were already using magnets to generate the electricity and we didn't want that to conflict. So that was one of our first design considerations that we made. And the second question about preventing water from coming into our device, we actually tested our device first without any of the electrical components inside of it to ensure that we didn't have any water coming into the main section of the device. And if we did have any water, we did purchase some waterproofing spray to ensure that it wouldn't leak into the device. But we did see that after half an hour's usage of the device, we didn't have any water coming up inside.
Okay.
That's great. Anyone from team U want to comment on the questions?
Sure, I can handle that one. So as regards for the spring part, our team actually didn't use any springs in our design. We did consider it at the beginning, but however, after talking to some of our advisors, we decided that using just a natural oscillator with magnet with a coil system would be best, because we found that friction and possibly using a spring would dampen the actual energy that we're getting into the system. The spring does help when it comes to small oscillations, but if you're trying to get wave energy from anything more than 10 centimeters, it does become a bit more problematic. So that's why we didn't go with the spring design. As for the actual sealing of the device, we actually have a O-ring inside wherever there is anything that contacts the water. So our main objective was to reduce friction there, and also we tested it in water a couple times, and we were able to make sure that no water goes inside using basically like a gasket O-ring sort of mechanism.
Okay, thank you very much. Rajiv, you have a question?
He's on mute.
Oh, yeah, Rajiv.
Sorry about that.
Okay.
The prototype was fully functional and was acceptable by the customer?
Which team?
For team U.
For team U, okay.
Yes, so for our design, we actually did test it. We actually created this mechanism, which actually, since we didn't have access to the lab in the bird run, we actually took apart a bicycle I had and a scooter, and we sort of rearranged it and rigged it to run with a motor. And then we actually had it oscillate the generator back and forth, producing electricity from 0.5 hertz to 10 hertz range. So that was one of the main requirements from our customer. So using a microcontroller, we controlled the speed of the motor, which then controlled the frequency of the oscillations. And we were able to produce significant power within that range. With our testing, we got up to around 3 hertz. Unfortunately, the motor we were using didn't go up to the 10 hertz that we wanted, but using the data, we could sort of extrapolate that it would work within that range. Yeah.
I actually have a follow-up question for Team U. You guys tested on a regular periodic oscillation. Well, in reality, waves are going to be totally random, and you could have smaller oscillations or huge oscillation based on whatever's going on, right? Based on the gravity. So now, is that because you guys were aiming to go for those periodic oscillations, or that was just something to simplify your design for now?
For the most part, it was to simplify our design because that's where we can sort of test things a bit more accurately. It does give us an opportunity to actually make a consistent mechanism and then specifically test those different ranges that we wanted. Of course, in reality, waves do not oscillate in that very rigid frequency, but by showing that it could operate within that range, that was sort of our main goal in using specific frequencies.
Okay, that's great. Before I go to Farouk, I just have some question here from the students, and this question can go to either both Team V and W. But when they talk about they achieve one of the requirements or one of the achievement of the project is they're eco-friendly. How they define that? What's eco-friendly, and how they make sure that their product is eco-friendly and doesn't affect the environment? If you can just comment on this. We can start with Team. We can start. Oh, yeah, okay, Ashif, we can start with Team W. Go ahead.
Okay, so for our project, what we did to achieve eco-friendliness is implement a cradle to grave. Instead of having a cradle to grave option, which is the end of life cycle use of a product, instead of dismissing that product, we could recycle this. So in our system, we implemented that by reusing most of the components of an actual window AC unit. So usually the dismissing project of this would be just being thrown out into the landfills and just fill them up. And the risks of that is also the refrigeration leaks within the cycle, which is really bad for the environment. So in our project, what we've done is disassembling the whole refrigeration cycle carefully and reusing most of the components that otherwise would be expensive to acquire, as well as not as environmentally friendly, as you are like putting the environmental impacts of a whole new refrigeration cycle with its components and its environmental impacts as well.
Okay, thank you. Anyone from Team V want to reflect about how they make sure that it is environmentally friendly?
Sure. Josh Kettle. The way that we took the environmentally friendly aspect was to make sure that we chose a refrigerant that had a GWP or a global warming potential is within specific guidelines that are better than others. For instance, refrigerant that is R134A is better than R22, which is an older refrigerant. So our design initially started with R134 because it was better performing in the environment as compared to CO2.
Thanks, Josh. Farouk, you still have a question?
Yes.
Okay, go ahead.
My question is directed to Team T. Honestly, I was very I love the design. It's very interesting. But I guess my question would be, how would you transmit the electricity that the device is producing? And does that have any impact on how it behaves in the water?
Oh, so you talk about one of the linear generator projects. Which team? Your Team U?
Team T.
Okay. T? Yeah. Okay, sorry, Team T.
Tango.
Yeah, anyone wants?
I can take over. My name is Ramil Kazan, and I'm not sure what you mean by transmit, if you're talking about supplying to like the application.
Yes, so like you're producing electricity. How are you taking that outside of the device and transmitting the electricity to use later on?
Okay, so for the scope of our project, it was more of like just generating the electricity, not so what the application would be. But for our device specifically, it free floats into the ocean. So when the electricity is produced, we would tether electrical cables to the ship itself or whatever application. And basically the novelty in our design is that it doesn't need to be mounted to the ship or the floor. It only needs that tethering cable to transmit the electricity.
Okay,
Thank you.
Farhan, anyone want to?
Yeah, I got a question.
Okay.
So this is for all teams. I was wondering if you guys can talk a bit about what the capacity of each of your unit devices look like. So it could be the power generation for the linear generators or the water cooling capacity for the microfarming projects. And then what would it look like for you to actually scale that capacity up?
Okay, let's start with Team V. Josh or anyone of the team.
Sure. So our capacity originally started at 5 tons as dictated from Kenobi, but due to budget, mainly budget constraints, we had to ramp it way down to 0.5 tons, which is the cooling capacity of the actual chiller. This means that if we ramped it down to 0.5 tons, we could build a prototype which would closely resemble the actual 5-ton that we would need as the customer required. And then the modularity or the scaling up would just be multiple units put in parallel, which increases the cooling capacity overall, but not the cooling temperatures.
Okay, and if there is, did you do any calculation for any other challenges when it comes to the scaling up? Is it just you taking your unit and multiply it by 5?
Exactly.
Okay. Team W.
Okay, I can take this one. So for our requirement was also initially 5 tons, but as Joshua mentioned, the budget was not enough to get like a compressor, which is the main component that dictates that can provide that such a high cooling capacity. So we had to end up reducing it to 1 ton. Now the AC unit that we acquired was initially a 1 ton cooling capacity, but we're actually able to get a bit more than that because, as we all know, water is a better conductor than air. And we also, in our design during the critical stage, we performed calculations for the length of the evaporator coil, which is mainly what we changed. And we increased this length significantly. So we were able to reach actually a bit higher than 1 ton cooling capacity.
Okay, thank you. Team T. Emily.
Can you please repeat the question, if you don't mind?
So go ahead with that.
Scalability, right?
It was about the capacity.
Yeah, so what's the current capacity of your system? So I guess that would be the power generation capacity of your current prototype, if you will. And then if you had to scale that up while deploying it in the real world, what would that look like?
So at its current scale right now, it is capable of producing an output that meets a USB 3.0 standard. So it can light up an LED or a flashlight or some kind of USB device. Scaling it up would require the mechanical component of this system to be larger, or adding like making it modular and adding more of these devices in parallel together. And that would produce enough output to maybe fast charge a cell phone or power up a larger device through USB. That's how we were planning to scale it up. Basically, it would be either the size of the entire device or adding multiple of these devices in parallel as modules.
Okay, thank you. Team U.
Yeah, so our current capacity that through testing we found was around 10 watts. Obviously, this isn't enough to actually be used on any sort of real application other than as just charging your phone, or even maybe not even that. In terms of scaling, we sort of fall into a unique problem where we can't increase the frequency of oscillations because that sort of stays constant. Maybe it will go from 0.5 hertz to 10 hertz. So then you have to increase the magnet size, the coil size, or even put multiple one of those together. So that does change the design quite a bit. That increases the amount of weight in the system, the amount of friction and all that you have to overcome. So increasing it will definitely be a challenge in terms of scalability for this project. But it definitely is possible if you change up the sort of internals in the generator, changing up how the coils are connected, maybe using a multiple magnet setup, increasing the magnetic field, for example, can increase the output. But yeah, that's definitely something that will definitely be a challenge.
Thank you.
I have a question.
Yeah, go ahead.
I guess like both the chiller and the tidal wave energy generator, these are not new technology. There's existing technology in the world that does something similar, may not be the same method. Can you, I guess, especially for the microfarming chiller projects, V&W, what would you say is your innovation on your projects? Like that, what sets your project apart from what's available on the market?
Yeah, I can take this one. For Team V, the novelty of our design is its size. Commercially, the smallest possible units, as we were mentioning, was 55,000 watts. Right, ours is 0.5 kilowatts. Right, so it's about the size, and the whole purpose of the project was not to add anything because we're just using the refrigeration cycle, the basic one, but what we're doing is implementing it at a small scale so that it can be taken to those rural areas for our client to use. That was the purpose of it.
Also, in addition, the novelty was that, say if you have a 55,000 ton cooling capacity and it breaks on you, you have to replace that whole unit. Whereas if you have the modular and you have 1.5 cooling capacity that breaks on you, it's easily replaceable, and you can achieve that same overall total cooling capacity that you had with a bunch in parallel.
So I would like to take this question. My name is Yasin. As David mentioned, we were able to reach a bit more than 1 ton cooling capacity. And when you're comparing this with the already existing water chillers, they're around 10,000, like between 8 to 10 grants. And when you look at our budget, we were able to reach that in less than $900. That's what something we did with the budget we had.
We still have 5 minutes. I would like to ask a question, maybe if briefly every team can reflect on it, is and some already did when they're talking about answering some other question, but it's all hard. It's a prototype kind of projects, and I'm wondering about looking forward 1 year or 2 years to reach implementation phase or an actual application. What do we need to do to get into that stage? I understand that some of you was proof of concept, so it might not reach that stage, but if you are planning to take your project to implementation a year from now or for commercialization, what do you need to do from now to reach that stage? If every team can reflect just for a couple of minutes. So I'll start the reverse way. I'll start with Team U.
Okay. So with our project, we found that we were actually able to achieve the output power that we wanted to. In terms of taking it forward from here, it would definitely be improving on the design in terms of mechanical refinement. So that, for example, improving the mechanical design to prevent any leaks, and also improving the electrical design in regards to implementing a converter, a voltage regulator to ensure that the output is a constant, steady stream of voltage. Also just figuring out how our storage unit's going to be. Also, additionally, we wanted to implement this design on a maritime, like naval ship. Looking into how that would work, we would have to look into the regulations in terms of that. Would it be recreational craft? Would it be large vessels? All that sort of stuff has to come into consideration. But yeah, I think the most immediate next step forward from taking our current prototype is refining the design into making it a bit more efficient, and something a bit more in line with what's currently on the market in regards to rotary generators that you usually find everywhere else.
Thank you. Team T.
Kareem Zaid. So in terms of years down the line, I'd say that providing a budget for a larger budget compared to the moment for our project would make not only scalability to be larger, but also to be able to utilize more efficient ways of, let's say, turning the coils around for the magnets to create the electromagnetic field for our input for the next stage. In addition to, if we have, let's say, a higher power output from our mechanical side going into the input of the electrical system, it will be able to help us to find a better way to use a converter that converts higher voltages, and this will provide for us a higher output. And the point of it is that we're trying to find a range of power outputs that we would be able to use for different marine applications, and hence it was a must to be able to see what each application might utilize in terms of power, and then we would try to work accordingly with regards to that.
Thank you. Team W.
Mr. Hassan, go ahead.
I would like to talk about the uniqueness of the prototype and how it could be used for commercial purposes in the future. So in terms of the evaporation process in our system, we do not really rely on a heat exchanger as a mechanical unit itself. We incorporated evaporation coils inside a water tank, which really decreases the budget that we need to come up with a full refrigeration cycle for a certain cooling capacity.
Just to add on this, on the long scale and on the long run for a project, what I think would be actually very viable is the automation process and the control system. So optimizing our code and our control system to make it smarter in a way to actually optimize the growth of the plants in terms of the cooling, like in terms of the cooling temperature and dispensing temperature that would actually feed the plants. So plants, like at each stage, require different inputs, like they need different requirements at each growing stage. So what we'd like to do at the long run is to optimize the smart system to actually reach the required temperatures at each growing stage. Plus the modularity and the capacity of our system would have to be increased to meet with growing microfarming demands.
I would like to add something. My name is Yasin, I'm from Team W. We were able to test our mechanical components together. So we added water to the tank and we tested, we had the evaporator coil inside the water. We were able to reach the objective and the goal temperature, which is between 15 to 18 degrees in the time that we calculated. So increasing the budget to make our project modular, that would help us, first of all, in testing, and will help us in implementing it later on. Thank you.
Thank you. Team V.
Yeah, so my name is Jacob, I'm for TD. Basically, when we're looking at the future next year to what our plans would have been, the first thing we would have wanted to do was get more budget. There's a lot of things we still need to do with testing that required more budget, and we used up a bunch already. So we were actively looking for sponsorships kind of right before this situation happened in our world. But after we were able to maybe secure some more budget, we had some more testing that we'd have to do when we get, say, sensors and some better facilities on things like capacity, temperature, like flow rates, all that stuff, leakage. And then maybe even further down the line, once all that's done, we would actually have to go and work with Kenobi to try and implement it into their facility and their work, because we are using their technology, their sensor, or sorry, their system and code to kind of work with our system. So the whole idea was, in the end, it would easily be implemented into their facility. So we would kind of want to continue with that.
Thank you. Okay, so that's the end of our session. I would like actually to thank everyone who participated and people on the back end of it that we didn't actually able to see them or chat with them. And very good job. Thank you very much. And at this point, I would like everyone who haven't raised their hand yet from panel 4 to do so. And we can actually now, friends can take charge of for panel 4. Thank you.
Hassan. So we're on to the last panel before the break. And in this panel, we have the next 4 teams. We have the automotive optical sensor cleaning team. We have 2 teams looking at the hybrid rocket engine. And then we have the first of 2 teams looking at a screening system for stem cell-based drug dispensing. The second of those teams will be in a later panel after the break. So if we could go ahead and roll the video.
The main objective of our project is to create a cleaning mechanism that can successfully detect, clean, and remove deterrents on the surface of a car sensor with minimal human intervention, thus providing a safe and reliable driving experience to autonomous car users. To summarize, our proposed design is expected to endure extreme weather conditions ranging from -40 to 60 degrees Celsius, is manufactured adhering to industry standards, is produced and manufactured within a budget of $1,000, and also has a warranty of 3 years.
The function of the mechanical module is to solely remove contaminant from the field of view of the acquisition device. The task of decontamination can be broken down into 2 subtasks, detach and remove, which will be carried out by the fluid and wiper submodules. Initially, the fluid mechanism ejects fluid to lubricate and detach vast majority of the contaminant from the window, and the wiper module will physically remove and drain the mixture subsequently.
We created the Polaris thrusters, or PT-1000, a small-scale hybrid rocket motor. Affiliated with York Rocket Society, we are looking to further a fundamental keystone in the development of human technology, exploration, and survival in modern times.
We decided to use ABS plastic as a solid fuel source and gaseous oxygen as the oxidizer.
Our original design had a cylindrical port, but with the goal to optimize our design, we chose this web-like shape instead. This is because this design increases the overall surface area of the fuel port, which increases the mass flux and the total thrust output.
The combustion chamber is the channel through which the oxidizer flows from the injector to the nozzle. We manufactured it in-house at the Bergeron's machine shop. The hybrid rocket engine has a control system which can initiate ignition and modulate the thrust of the rocket at a safe and remote distance. This is the graphical user interface for our rocket. It consists of various displays for sensors and the ability to also remotely actuate ignition through a switch.
We are Team Q, and our project was a hybrid rocket engine. This project is one of the few rocket engines designed by undergraduate students at a Canadian university. Rocket engines are an essential part of the space industry. Businesses and governments increasingly depend on them. Therefore, it is crucial to harness experience and knowledge in this field as soon as possible. The main objective of this project was to design and fabricate a testable model hybrid rocket engine that shall produce thrust at a target value within acceptable deviations over a predetermined time period. This video shows the assembly of our final design. We put in upwards of 1,500 hours into this project. At the current time, we are close to finishing, and we hope to complete our work before the end of the summer if the context allows for it. Our final design is expected to produce around 500 newtons of thrust. We are using acrylic as our solid propellant and gaseous oxygen as our fluid propellant. The image here shows several of the main components of the project. The ones here are the combustion chamber and the injector bulkhead, the nozzle, the injector, and the acrylic tube. Not in this image is the igniter, the fluid propellant, and the fuel line. The engine is 19.5 inches long and has a diameter of 3.5 inches. It weighs around 9.4 kilograms.
Dr. Terry Sashnos' Stem Cell Engineering Lab is investigating methods for blood stem cell growth for later implantation. The process works by harvesting an individual's blood stem cell from their umbilical cord at birth. from which it is grown in vitro in a 3D scaffold with growth factors for later implantation into the patient's adult body. That can be done for cases such as leukemia, requiring bone marrow transplants to the patient. This requires finding the ideal 3D scaffold design and growth factors for necessary growth of the stem cells.
Here's a quick look at how it works. The x-axis is driven by belts, and the y-axis is also driven by a belt. The z-axis is powered by a lead screw that allows the syringe pump to be lowered up and down. The syringe pump is also powered much in the same way that the z-axis is, but it has a lead screw that drives the carriage seen on the outside in red that pulls the plungers up and down, allowing liquid to flow in and out.
Thank you very much for our 4 teams. So obviously this panel is focusing on some fairly different hardware and electromechanical systems. And I will actually start the questions off with a question around, in light of the different applications that the groups had, what was driving your material design choices and what challenges did you face in this? So if I could go to our 2 rocket engine teams first, Team P.
Hi, I'm John. I could answer that question. So primarily our design was focused around the manufacturability of it due to the limitations that we had with access to like a proper machine shop and obviously what happened during the entire coronavirus thing. We've been really trying to focus on getting the design to be optimized for producibility within our resources at York. Obviously machining of something, outsourcing is so expensive that within the budget of our design, without external sort of support, it wouldn't be possible to support that level of production without much higher investment, basically.
Okay, thank you, Jonathan. Team Q.
I can take that. I don't know if you guys can hear properly, but we were driven mostly by safety. So we had, of course, cost concerns. So that's why we chose stainless steel over other materials. But most importantly, we want that on the day of testing, we know that our combustion chamber will withstand the pressures that are generated by combustion. And so that's why we went with a very strong and durable material.
Thanks, Mathieu. And Team K. We have somebody from the automotive volcano team.
So I would like to take on to that question because our projective is mostly focused on extreme environment and also the surface life over 3 years. So we're looking at durability, manufacturability, and also like extreme condition. And because we're 3D printing most of the material prototyping, so there's like a trade-off between heat extrusion and also the temperature range of the material.
Thank you very much. And finally, Team Z for the stem cell screening system.
I can take this one. So we chose the frame made out of aluminum. That's because of cost requirements. There are a lot of safety requirements for making machines that work in clean rooms. So aluminum is the cheapest option. It needs to be anodized in order to get lab safety level 2, which was our goal. It's still possible to anodize our design. For now, it's unanodized just for cost savings because we were really tight on budget. But that was most of the concerns that we had with materials. We're all trying to get things to fit within the lab safety requirements. So stainless where possible, anodizable aluminum where possible, and avoiding any kind of porous materials that can hold on to bacteria or other undesirable materials for infection and so on, sterility.
Thanks so much. Okay, I'd like to open it up to the judges if there are questions from the judges.
I had a question.
Thank you,
this is for both of the hybrid rocket teams. So how are you guys planning to validate that your designs actually produce the target thrusts that you guys are looking for?
I can take over here. So the validation with the amount of thrust that we are going to produce is actually very complicated because it's a very iterative process to figure out how much thrust we're actually producing. And because we weren't actually, our team wasn't actually able to complete the finalization of the project and test it, because typically you would put it up in a static test rig and then let it fire and record data with a load cell. So we could really only go off of calculations that we had. So there's a very long iterative process that goes along with finalizing some final number that we can at least go by. And this also factors in a bunch of assumptions and other types of factors that would naturally affect our production, because while we can obtain a theoretical thrust, that doesn't necessarily prove that that's what we're going to get. So a lot of thermodynamics went into this to kind of discover our control volume and what's actually leaving the system and how much we can actually quantify at the end of that.
Okay, thanks, Amanda. And if somebody from the other rocket team would like to take that as well.
I can take this one. So part of our design, so the initial stage was simulations through RPA, which was a simulation technique to see what exactly our thrust could get. For actual testing, we did have a test stand that we designed. And with this would be part of our final static test where we would fire it. And at the front of that, we had a load cell to measure what the thrust would be. We had that hooked up to a computer, and we did calibration through that to make sure that if we were testing it with weights, that we would get the proper reading. So this was something that was going to be done for a final test, that we could actually see what the performance of our rocket was.
Great, thanks, Michael. So we have a few questions from the attendees. I'd like to ask the next question to our teams K and Z. It's around the good manufacturing practice protocols. What consideration did you have thinking about good manufacturing practice, where ultimately your products were designed for more mass production? If Team K could take that first.
Right, I think I can take up for your question. For the mass, speaking of the mass production, there is different parts of manufacturing PCB and 3D printing the entire systems. We have confidence that the PCB design is suitable for massive manufacture due to its compact and easy, and all the materials, all the electrical components on there are easy to find. Is everyday electric components. For the 3D printing, we've used the 3D printer module with 3D printing material, which is also everyday found. We've did the material selections based off the accessibility for all the manufacturers, and we have confidence that it is really and we designed it such way that it can go into mass production.
Hi, I would like to add on to the mechanical component to K, because 3D printing is not really feasible for mass production. So in future, we like to move on to things like molding process for large production, because we have basically all our model is like a compliant mechanism, so it can pre-print into one piece. So we can have multiple pieces printing all at once at large quantities. So that will be onto the 3D printed components.
Thanks, Jifeng. And the same question for Team Z. What were your considerations around this?
So for our group, we were hoping ultimately to commercialize this venture. So we were thinking from the outset about how we can work out ways to work around the fact that this is complicated machinery and we don't have a big production facility or funding to pay for huge initial volume costs. So what we went with was a almost entirely commercial off-the-shelf product. So almost everything we used was purchased and not altered from the purchase. The only exceptions were our 3D printed parts. There are in total only 5 3D printed parts, and they can all be printed within a few hours. This is for scalability. For us at the stage we are in our venture, we need to start at a place where we can put this together at like 0 manufacturing and assembly costs so that we can preserve our margins and work for ultimately being able to redesign it for different audiences maybe. But for now, we want to be able to put it together for as little as possible so that we can sell it for our really low price point, because that's really one of our main selling points, that we can make it for so cheap compared to anybody else who has to machine all these custom parts or use injection molds or so on. So that was really one of our biggest design considerations in terms of our budget.
Thanks so much. Okay, so we have a question from one of our attendees who's also one of the supervisors of a couple of our teams from industry. And the question is for the two rocket teams. In aerospace, we often have to think about failure modes in coming up with a safe design. So I wonder if you could both talk to what were some of the major potential failures that you were concerned with, and how did your design address that? If we could maybe go to Team Q first this time.
Yeah, so I'll take that question. And I really want to focus on the biggest concern that we had was the final testing and any uncontained combustion that happened during that. And by that, I mean fires or explosions. So we were really conscious of any hazards to personnel and to property. So we made sure that we had the proper safe grounds to make sure that didn't happen. So it was part of our material choice, which we brought about earlier. And we also many redundant systems, such as the injector bulkhead, where we had, in addition to O-rings, we had other sets of screws to keep everything in place, to avoid, in the case that something goes wrong, we have explosions near flammable materials.
Thank you. And if we can go to Team P, same question.
I'll take this one.
Oh, sorry. Go ahead.
Okay. Like the other group, the final testing was our main concern. In terms of material choice and the overall design, we ensured that the minimum safety factor for our design was about, I think, 5 in relation to the screws and bolts. Outside of that, we ensured that there wouldn't be anything else that could happen. So we had a very long oxygen feed system with backflow arresters, shut-off valves, automatic systems that would shut off, or manual shutoffs that we would be able to intervene if we notice something going wrong. We also had RTDs and pressure transducers, so they could automatically sense the input data from our system. So if something went above a threshold limit that we would set up, we would allow it to shut off automatically.
Thanks, Ayab. Okay.
If I could add to that point, sorry.
Please.
An additional thing was that we needed to maintain a safe working distance for any personnel who would be anywhere near the engine. So a very conventional thing that a lot of hobby engines and other rocket engines would do is create a blast radius that's equivalent to a certain level of TNT explosion. And that basically dictates where a safe radius around the engine would be that any operators could be outside of. And this was really critical in determining how far away certain sensors or controller data needed to basically be wired to, so that any operators would never be in a certain radius to maintain the safety of if something went wrong. Because even with sensors and stuff for our data, the engine's operating at a very fast rate, basically. So if something went wrong, it's mostly unlikely that you would be able to shut it off in time. So that's just an extra level of protection that we had, as well as our safety factors and everything.
Thanks, Jonathan. Before I go to the next question from the attendees, are there any questions from the judges?
Sorry, go ahead, Dora.
So I think we've got Vidushi and Akash. If Vidushi, you want to go first?
Okay, I have a question for Team Z. I did see that you went through a lot of iterations of what the adapter needs to look like. You said 47 different designs. I want to ask you, how do you monitor how much liquid is being pulled up into your tube such that the little test plates don't overflow when you dispense them?
Okay, if somebody from Team
sounds like some of my team members are having some audio trouble, so I'll take this one too. So the way we monitor the water level is by the stepper motor. It only moves, that powers the lead screw that causes the aspiration to occur. So the way we do that is it's all digital. So we don't need to check the water level visually or with anything else. We just know that a certain number of steps will correlate to a certain amount of liquid. And then after every aspiration, we eject the pipette tips. So there's even right now we actually over exhale so that there's no residual. And if there was, it should be pushed out by the extra little bit of volume ejected. But if it's not ejected, then the entire tip is taken off for the next one. And that's important for sterility. That was one of our design requirements. So the way we determine how much liquid is in the pipette tips is through calibration through our stepper motors. So that was by far the biggest challenge for us, getting that figured out. But ultimately we got it down to plus minus a microliter, or half a microliter actually, which is within our requirements. And we worked so hard for that, and it worked out. So if that failed, we determined that the project would have been a failure. So when it succeeded, we were really, really happy. It took months of work to get that.
Great, thanks, Emmett. Akash.
So I have a question for the optical sensor team. You guys said you guys had the design for durability and severe conditions. So what kind of tests were you guys planning to validate that?
So I'll take over for this question because mostly the extreme condition and the surface life will be on the mechanical component, mostly on that. So the test we did for extreme condition is just looking at the levels that decline by the client. So was just minus 30 degrees Celsius and positive 80 degrees, which is, we can test it for our plastic components, our mechanical component, which is the majority, and also our fluid module. So we just basically use a fridge for the minus 30 condition and then keep it there. So we have two conditions. We either keep it on and then just have it tested once a while periodically, or we keep it operating and test if there's like a fatigue of the lifetime. So we test multiple, test both extreme condition and surface life fatigue simultaneously at the same time, so at both extreme condition and surface life.
That's what I was looking for. And just another question: did you guys figure out like what kind of, how many cycles does it need to go to? Like, did you guys come up with a cycle number? Like it needs to pass 1,000 cycles in -30 or something like that?
Because we're only estimating that winter is mostly in Canada. Winter is a half of the year that. So we can take, for a surface life of 3 years, it's majority almost 1 million cycles. So we can just do a quick estimation of half of that. That will be the estimated cycle of the condition where it will be in extreme cold. In the extreme hot temperature, we'll be looking at another condition because it's not in Canada. Yeah.
Okay, thank you.
Thanks. Time for maybe one more question from the judges.
I have a question for Team Z. While using these adapters and testing the ability of these fluids that don't leak from the adapters, I know you put in a lot of effort in finding the one that did not leak. Did you use different type of fluids so that there is no possibility of leakage in fluids having different viscosity?
So I'll take that. I'm Mateo from TZ. The reason why we didn't use different types of fluids is because the fluids that we were to be injected into the stem cells are primarily a water-based fluid with a little bit of nutrients to feed the stem cells. So we didn't necessarily need to try out different fluids inherently because it was all going to be based off of water. And in the end, we didn't get the ability to fully test the media itself due to time restraints and what happened towards the end of our project. But with the stand-in the leaks didn't happen. So that part of our project was considered a success. And I'm sure that we wouldn't have any issues with different viscosities either, as long as they didn't range too far from what we had been using.
So how close are you to provide testing facilities for coronavirus?
That's something definitely that we wanted to look into. I'd like to say that we're pretty close, seeing as we were very close to finishing the project, but I mean, we're still a little far away.
Good job.
Thanks, Matteo. Arma, did you want to jump in at all?
Matteo covered very well. That's fine. Thank you very much.
No, thanks, Arma. Okay. So we have another question from the attendees. It's probably our last question from Teresa. For all teams, if you can keep your answers short, what was the biggest design hurdle that you faced, and how did overcoming that design hurdle affect your final design? So if we can go to Team K first for this one.
Sorry, can I ask David for this question?
Right. Go ahead.
I think for our team is about the physics. The way how we do, or how we do is how to get the data from the physical environment into the digital data, so that we can do software development. The major challenge is about mechanical testing. They got a shopping list in terms of selecting material, and they have to spend lots of time on the simulations. And after that, they get a good direction on the material selection. And then the next stage, we got to do the real testing on physical environment to ensure that the selected material is good for our design. Thanks.
Thanks. Okay, if I can go to Team P.
Okay, so I'll take this one. Our biggest challenge that we faced was definitely overall just fabrication and manufacturing. And that got a lot more complicated as we moved through the system. So there's a lot of subsystems that we had to cover, and our project shortly became a bunch of larger little projects underneath the big project that we had. So by the end, especially when we reached the nozzle, like we were looking into additive manufacturing, like 3D printing steel, we were looking at thousands and thousands of dollars. So it turned into having to almost go through the entire project again and rebuild it from the beginning, and what kind of products and what kind of materials will we use all over to start this project and make it more efficient and effective for us to complete at the end of the day.
Thanks, Amanda. Team Q.
All right, so I'd say for us, I mean, we faced a lot of hurdles as the entire topic was new to us, but probably the largest was there was a huge amount of work expanding our scope to actually create a test stand, because initially we had assumed that we'd be able to find a suitable location for testing, that we'd be able to kind of design around that. But once we realized a few months in that we actually had to create that ourselves, it added a huge amount of work and just designing and tests for us to do.
Thanks, Ariel. And last but not least, Team Z.
I'll take it. I'm Arma. And one of the main determining components for our design was to ensure precision. So we wanted to achieve a tolerance of 0.5 microliters in precision for our adapters and our pipettes when they were sucking the liquid up. So we did achieve about 0.7 microliters after the 47 tests. So that was one of our biggest factors. And also a smaller factor was making sure our project was within the of $1,000, so keeping it affordable for smaller labs and academia and such. So yeah, I think we've achieved quite well in terms of our design problems.
Yeah, thanks, Sam. I think you've all achieved really well. So thanks for that. So that's the end of panel 4. Thank you to all the teams in panel 4. We will be now taking a 15-minute break, a chance to go and grab a drink, take a short break, and we will be back at 11:15 with panel 5, and that will be with Hassam. Are there any announcements that we need to make prior to that? Gayatri has mentioned that if you're in panel 5, make sure you have your hand raised in the attendee list by 11:10. Are there any other notices? If not, we will see you back here in 15 minutes.
Hi.
Sorry, I was actually compiling the announcements, so yeah, I couldn't do it much.
From my point of view is going smooth, actually much better than I expected. So
I just
okay, that's
yeah, she just tweeted that.
yeah, okay. So yeah, looking good. I mean.
Just a quick question. So it will be me doing the next panel? Franz said that it was Hossam doing the next panel, but I think I'm scheduled to do it. Okay, we'll be getting started in about a minute or so.
Those videos are really nice, the kind of session videos.
Oh, the summaries?
Yeah.
I
mean, just kind of the arrangement with like the little entries.
Yeah, am I speaking the right session? Okay, just doing a mic check here. Were you hearing audio on the main room? Yeah, okay, excellent. Franz, can you confirm that you're hearing me from the main session? Okay, excellent. Thanks, Sandy. Okay, so we will get on now with the next panel. This is panel number 5, H, AA, and S. Okay, the team H is the Moodle kiosk team. Team AA is the screening system for stem cell-based drugs, and team S is the wind mapping for better forest fire management or forest fire fighting. We will queue up the video now, and then we will move on to questions.
Our client is York University's Glendon campus IT department. They offer their support through their website as well as through their help desks. The trouble with that is the slow service, which stems from having to queue in front of the help desk or having to wait to hear back from the department. Our final solution is a web app that runs on kiosks, mobile phones, and a variety of other computing devices. The app utilizes UI interface as well as AI. Our project extends its services to York University's students and faculty. These services comprise IT services, financial services, and other essential school services, with room for inclusion of more services in the future, such as the ongoing wayfinding project.
This is the mobile version of our app. We hit the drop-down menu and it shows us a list of services. Select IT services, select change password, and it takes us to York University's guide on how to change password.
Wind tracking is the process of tracking wind. While this may seem straightforward at first, there's a chance you might be thinking of the wrong thing. This is because wind tracking can come in two different forms, global and local. Global wind tracking operates on a large scale, usually spanning cities or sometimes even countries. Local wind tracking, on the other hand, maps the speed and direction of wind in the vicinity where the test is being conducted. The application for this is much different than global tracking and is what our product looks to achieve. Local wind tracking is used by a wider variety of clients than you might expect. From forest firefighters to researchers like our client, there's already an established market. With an already established market comes an already established product. Or two in our case. Both of these products have their downsides. The theodolite is fairly cheap but requires a user to manually operate it, while the radiosonde is a more expensive alternative which comes with the benefit of automated tracking. Our goal was to rectify both of these problems to create a product that is the best of both worlds. By using a camera to automatically track the movement of a red helium balloon, we were able to convert the positional data of the camera into a mapping of wind speeds at different altitudes.
There you go. Cool. Okay, thank you for the video. I hope everyone got to see that video right there. So we have 3 teams. We have the Moodle kiosk team, we have the Spencer or stem cell drug team, and the wind mapping tracking team as well. Did anybody want to start with questions for any of the teams?
I have one if I could.
Yeah, fire away.
So my question is for Team H. I'm really curious to hear a little bit more about what computational challenge you were looking to solve using AI and how you did that.
So Team H is the Moodle kiosk team, yes. So would somebody from the Moodle team like to, or the kiosk team like to answer the question?
I'll have a go.
Hi, Sammy.
Okay, hi, how are you?
Good.
Yeah, hi everybody. Yeah, well, the way I understand it is that it's not computational challenges more than how well the AI is trained. The more you train it, obviously, we had to start at an acceptable level, but the more you use the AI, the more it trains itself. So first you determine how well, what kind of level you want to start with. Like when you start, publicizing the app and asking the students to use it. That's the initial level. But as the students and faculty use it, it trains itself more, and it improves itself. And any challenges would manifest themselves in the AI being able to understand the question, whether it's being asked like appropriately in the best way that you would word the question, or in written in the way that we write texts, like you write you as a letter U instead of the word you and things like that. But yeah, so the challenges get easier as you use the AI. I hope that answers the question.
I see. So it was, the challenge might have been just kind of interpreting and classifying the questions, and to learn from that.
Yes.
And then, and just what kind of either framework or backend supported this? Because I see you had a mobile app, and I was just wondering. I mean, were you using web services? Did you have that in place, or were there APIs available to you that you leveraged? Because I mean, that alone can be a lot of work, and I was just kind of wondering, just briefly, what kind of assistance or framework might have been used.
Okay. In terms of the training the AI, we used IBM Watson, and yeah. So you train the AI using IBM Watson, and then when you're satisfied, you kind of like you almost import it to your app, but you still get it. You're still getting your information from there. So when a user asks a question, we send requests to IBM Watson to be able to fetch the answer. So it's still happening through IBM Watson. It's not IBM Watson's role doesn't end, hasn't ended, right? So it doesn't end at the end of our project. It's just it's still is used with the app.
Thank you, Sami. Okay, thank you. Can we move on to the next question? Does anybody have either a follow-up question or a question for one of the other two teams?
I have a question for Team S.
Yes, please.
For the camera tracking, what is the range and that you can track the weather balloon or whatever you are using for the wind tracking?
So this third team, yeah, Ben, would you like to answer that question?
Yes. So as per the requirements, our client initially wanted a 2,000 meter range, and so that's from the requirements. But from the actual implementation, we weren't actually able to test the functional range. So as for like an estimate, it can probably go up to like 500 meters when it's fully complete.
Louis, were you able to hear that? So he was saying 500 meters.
Yeah, I didn't hear the last bit.
Okay, so he was saying 500 meters.
Yeah, that's
okay,
like our estimated like theoretical value.
Okay, thank you.
Okay, did somebody have another question?
I got one, James.
Oh, there we go. Yeah.
Okay. Should I go ahead? It's okay?
Yeah, go ahead.
Okay, I have a question for team 8A, the automated liquid dispensing team. So in your design, I saw that your extrusion mechanism was attached to the bottom of the device. Now, and you guys use tubes to attach it to the Z head. So now, is there a reason you guys went with that approach, or maybe could you have gone with the smaller stepper motors and just gone and attached it to the head itself? This would have eliminated a lot of variables in the middle, and maybe it would have made it more accurate. I'm not sure. I just want to know your opinion on it.
So this was for the stem cell team.
Yeah.
The stem cell team like to field the question.
Yeah, I'm gonna take over in this one. So we did consider putting it in different locations. The kind of takeaway we started to look at is the gantry or the head that moves around would get very complicated if we went with that option. So we considered putting it elsewhere in the design. As you said, it's in the bottom. We have lines connecting. Inside there, we put basically liquid, so the dispensing is more accurate because of the compressibility of air. And when we considered that way of designing, we did come up with the question, well, is this going to be more accurate than the other option? Well, at that point, we kind of went with the idea, okay, this is the kind of possible way to go at it. And if it's not as accurate as we were thinking, we did have a second iteration of the design to go with. But shamefully, we couldn't really test the accuracy of it in terms of actual testing the way we wanted to because of the situation we're in. But what we found is that using water, which was the liquid we chose, the accuracy improved quite a bit. But we would like to test that further.
Thank you.
Goodyer, did you have a question?
Yeah, so my question's for the wind mapping team. So you're optically tracking a weather balloon. How do you ensure that it continues tracking it if the balloon were to fly in the direction where the camera is directly exposed to the sun and your image just blows out?
So yeah, that's of course an issue because the way that we're tracking the balloon is just based off of like the color features. So our control algorithm doesn't really take into consideration when it loses sight of the balloon, and it assumes that once it reaches that position that the experiment's over. It should probably be up to the experimenter to orient the system such that it might to minimize that risk, but it is a hazard. Like we have limited computational resources on the platform we're trying to use, and a lot of the things can't be taken into consideration just because of that.
Well, I guess in terms of experimental setup, you can't really control the direction of the wind.
Yeah, that is true.
So just something to think about.
Good suggestion. Okay, did anybody have another question for the teams?
I've got a question, if I may.
Yep.
So my question is directed to the stem cell team. Obviously, you've done an amazing job with your project, and I think everyone would agree that it's very well polished. So kudos on that. But the cherry on top for me for that video would have been seeing a user interface. I was just wondering, did you ever get a chance to develop that?
So Farouk wants to know about potential for a user interface on the stem cell project.
I think I'll grab this one. So yes, we were able to develop a user interface. We chose to use C# as the coding language on Visual Studio on a .NET framework. There was an initial layout that was created for the user interface for each individual stage, going from scanning, from seeding, from extrusion. It wasn't necessarily shown inside the promotional video, but it was created. Sadly, we weren't able to directly connect it to Spencer as we were still looking forward to the testing phases. So we used an intermediary software, which is relatable to something similar to 3D printing softwares known as Prompterface, to input G codes instead. But the baseline framework for the UI was created and it just wasn't showcased.
Great job. Thanks.
Okay, did anybody have any follow-up questions?
I had one question for the Moodle kiosk team.
Okay.
So your interface is potentially going to be taking in personal information from a wide variety of people. How have you dealt with the privacy concerns about the data that you're going to be receiving? Is it staying on site, or does it have to go off site to be analyzed by IBM Watson in the cloud? So how did you address the privacy concerns with the information you're gathering?
Okay, so it's a privacy issue question related to the kiosk group.
So I can take this one. So we're not handling too much personal information, and all authentication is happening through the Passport York system, which is already in place and already follows many of the security guidelines and regulations. For IBM Watson specifically, we're not actually sending any personal information to them directly. It's actually part of their terms of service that they don't handle any kind of private information like that. So we're not dealing with sending them any information in that respect. Furthermore, the servers that our software actually runs on are hosted by Glendon. It's their own personal web servers, and so they have security regulations up to date on that.
So privacy concerns are a very contemporary topic these days, and so it sounds like it's something that was considered from the ground up with your team. Okay, did anybody have further questions?
I had a question for Team S, the wind tracking.
Yeah, go ahead.
I'm sure it's difficult to mimic the environment of a forest fire, but what were your testing or experimental setup type of conditions that you were considering if you were to be able to test it in the certain condition of like a forest fire? Were you guys thinking about that kind of setting, or were you just going to test it the way that you showed in your video?
So the question was with respect to the wind tracking team's work, how testing would occur or be planned for under actual fire conditions. Yes? Okay.
So our tests that we plan to carry out were intended to cover like a wide range of environments. So we are trying to cover like a regular sunny day, low light, reduced visibility. And so that was part of our integration test. Of course, we weren't able to access all the equipment we needed to use because of COVID, so we weren't able to test everything. But yeah, we were supposed to as per our tests, have a whole bunch of different environments to test.
Okay. Is there would somebody like to ask another question?
I have a more general question for all the teams. I know as part of PO's partner with the Lassonde is that we provide industry advisors to most of the teams, if not all the teams. How I like to, this is for my own personal feedback, like how useful are the industry advisors on your capstone projects? It's not really directed at any specific team, but maybe anybody want to chime in on that? It's more for feedback purposes.
Would one of the teams like to tackle the question about involvement of industry in the projects? It's a big question.
Let me simplify that a little bit to break it down. Yeah, so to get general feedback is obviously difficult, but like would you comment on whether or not you actually had contacted the industry advisor, or vice versa? Have they contacted you throughout the capstone project? And that's one. And secondly, would their contribution helpful to your projects? I guess those are the two questions.
I could take this one, I think. So we had our supervisors was her main background was in the mining industry. So our project was directly correlated to the biomedical industry. So we tried to figure out some type of way on, and a lot of our questions were technical questions. So she made it very clear at the beginning that I may not be able to directly answer your technical questions, but I will be able to help you with team dynamic. So the key help which we received, which was actually very beneficial, was understanding how to learn within your team, using time management, addressing specific stakeholder requirements, which was very important for us because aside from what the lab had, there were specific requirements. She made it quite bold that often when engineers design for a product, they design thinking of what solution they have in their head without necessarily approaching who's going to be using it at the end of the line. So she made it clear that we need to be able to get surveys or approach people who will be using this. For our product, for example, it would be the lab assistants and or potentially like master's or PhD students. So we had to approach them and ask them, is this easy to use? Is the user interface simple enough? Yes, I think the supervisors were quite useful. We had consistent meetings with the supervisor as well. I think we had around maybe 4 or 5 meetings, and on top of that, if we weren't able to meet, there was good communication between us, sending emails back and forth, and even after the capstone, it was amazing having a connection from the industry, and our supervisor's been in touch with us, even during this pandemic.
That's wonderful feedback. Thank you.
So it sounds like potentially the interaction wasn't what was envisioned originally, and that just having sometimes technical feedback isn't necessarily what a team needs. But sometimes it's voice of experience, and I think a lot of teams, if I'm going to editorialize here, a lot of teams have discovered that team dynamics, the workflow process that you go through is as important, sometimes more important than the tech. Those personal interactions can be vital to that. Would somebody like to
I'm from Team S, and we didn't really use our industry advisor too much. We basically contacted him and he responded. Our team was lacking a mechanical engineer student, and we basically had 3 computer engineering student and a software engineering student. We asked him some question about the pan servo mechanism and such things, and he took a bit too long to respond, so we went ahead without his input. And we also consulted with your computer vision lab, like by ourselves, rather than seeking advice from the external advisor.
So in that case, having the availability of different resources sounds beneficial. Being able to know who to reach out to, depending on the problem that you're faced with.
It's better to have a mixture rather than an advisor, because you might get a really good advisor or you might not get a really good advisor. Like I would say ours is on that side, unfortunately.
So, but having a variety of
Yes.
of resources and people available, depending
Yes.
on the needs of particular teams.
Yes.
So it sounds like that's a need right there.
Yes.
Okay, excellent. This is good to hear some candid feedback from the students with respect to process.
I just wanted to add, yes, we didn't have input from our industry advisor, but we did get a lot from our client, and he helped us a lot throughout the process. So just wanted to say that.
Excellent.
I
Gives
just
a
want
variety of different experiences.
I could add a comment if I may. I felt that if we met the external advisor in person, that might have improved the experience. It might have helped us understand what this advising is all about. What exactly can we ask him? In our case, it was a him. And what can we know? We ended up asking a question, and I can't remember the exact answer, but it can't have been satisfying enough for us to continue asking, because we didn't ask any more questions after that. But I felt that had we met that person in person, maybe we would have established some sort of a report, and we got to know what this advising is all about.
Okay, super. Thank you, Sammy. So it sounds like a personal connection, knowing how and when to reach out is important. And so developing that personal dynamic is key.
Just to add on to what Sam said, our client is also in the industry, same industry as well. So he provided us with a lot of resources and help that we would have received from the industry advisor. So we leaned more towards satisfying the client as well.
Okay, excellent. Okay, thank you.
Can I just have
yeah.
one, like a summary sentence on industry advisors? I think the every feedback I heard is very valuable. I'm going to take it back to PO and obviously try to improve on that. But one thing to keep in mind is the industry advisor is not necessarily the technical expertise in that field. And we made that very clear, because when we select the industry advisors, his or her role is not to be your technical advisor, but rather giving you feedback from an industry on how practical can be, like someone mentioned about the team dynamics, can be the commercial viability, could be the project management and those aspects. That's what the industry is trying to provide you. Thank you.
Thank you very much. Yeah, thank you. So we are heading into the final stretch here for this particular panel. The panel number 6 will be starting up at 11:45. So for those of you who are panelists in panel number 6, that we in the group with team A, X, R, and AE, please use the raise hand feature. And with that, I would like to thank the panelists and the teams for having presented in panel number 5. So thank you very much. Okay, good questions, good answers, lots of things to reflect on and to think. Thank you very much. Okay, and so we're going to be passing it on to Hossam, who will be hosting the next panel.
Thank you, James. Yeah, I mean, I want to apologize that for if any of the panels there are some questions that there was some question was raised and we couldn't get a chance to answer them. Our apology for that. We're trying to cover as much question as possible within the time frame that we have. So we will do our best to look at all the questions from the chat room or from the Q&A and questions that we ask everyone to give us before ahead of time. We'll do our best about that. We're almost starting at 11:45, so when we start in a few seconds, we're going to start roll the videos for this panel. We have 4 teams, Team A, Team X, Team R, and Team AE. And if the video is ready to roll, we can start rolling the video.
In front of you is the assembly for the antimatter containment unit. Let's take a look at how it works. A high-energy positron is emitted from a radioactive source and is headed towards the tungsten moderator, after which the positron is accelerated to a known speed set by the voltage applied on the moderator. The positron makes its way towards the first stage of the trapping process, guided by external magnetic fields. The positron then enters a region where nitrogen gas is present. It interacts with the gas and has the probability of losing some of its energy. After the positron leaves the nitrogen region, it enters the second stage of the trapping process. As the positron approaches the end of the vacuum system, it undergoes annihilation as soon as it comes into contact with a free electron. This annihilation produces 2 gamma rays in opposite directions, which are then detected by gamma ray sensitive instruments.
Presenting UMTAS from Team X. Hey! UMTAS can start being used on the way to the site and is designed to get the user thinking in an accessible frame of mind. Recording things like time and weather is important because it can help determine what the evaluator was thinking when they were evaluating that location. When getting started, it is always important to be wearing the correct safety gear. Unlike here, UMTAS is designed to easily walk users through the steps required to evaluate a station. Sections automatically expand as needed to help save space and make the evaluation seem less overwhelming. Evaluations can be submitted later when we have an internet connection. Let's go inside. Oh look, a sign. Better snap a quick picture of it. That was easy. UMTAS can be used all throughout the station as you proceed on your way.
If we were able to get higher than a wind turbine, we would be able to tap into the near constant wind sources of the high skies. Kite powered generators would be able to rise much higher than wind turbines and could possibly cost far less. Our goal for this capstone project was to create a small kite generator for emergency situations. Our design has 4 main components: the base, the lifter kite, the messenger kite, and the tether. The base is where the power generation takes place. The messenger kite will be spinning a spool located within the base, which will then turn a DC motor to generate power. This is similar to kite power systems generation method, but on a much smaller scale. Now, while our system has 2 kites, only one of them is actually responsible for power generation. The lifter kite's role in the design is simply to fly high and exert a constant tension on the tether so that the messenger kite can ride the tether like a rail. This restricts the kite's movement and makes it significantly easier for us to control the messenger kite's travel up and down. So, in short, the messenger kite is controlled to fly up and down the tether. The upwards motion will be generating power as it spins the spool. Once the messenger kite is at the maximum height, the DC motor begins retracting the kite until the wind catches it again to restart the upwards power generating motion.
We are Instant Brine, the next generation of seawater desalination technology. One of the major problems our generation is facing is the coming water shortage. This is directly influenced by the depletion of our groundwaters. Globally, 70% of all fresh water is being consumed by the agricultural industry. The next generation of desalination systems will be generating irrigation water instead of drinking water for us.
Our method of desalination, which is best suited for irrigation, is spray drying. This method is very similar to the idea of boiling seawater to collect and condense the water vapor, except the water will be sprayed into the heat. Our prototype design closely resembles our flow diagram. We have a 5-gallon bucket to hold our inlet saline solution. The solution is pumped out of the bucket through a reinforced pressure hose that leads into the atomizer nozzle. We use the heat blowers as our heating system since it generates constant heat while maintaining high airflow. Another bucket with a coiled copper tube submerged within ice water is used to condense the water vapor as it exits the drying chamber. Lastly, we have a bucket to collect the water as it flows through the end of the copper pipe.
Okay, again, great videos and great summary of the videos. So we can start. I mean, if anyone from the judges have any questions, or the TAs have any questions for the teams.
I have a question for Team XA.
Yeah, go ahead, Lux.
So my question is that it starts off with, like, I'm aware from my own work experience working for the City of Toronto and other municipalities that they already have implemented other fieldwork management softwares that do exact similar things to what you guys have created. So what makes you guys different, and why couldn't these municipalities or businesses just use existing fieldwork management softwares and just create custom forms in them to do what you guys are doing?
Sure, I can take this question. So the idea comes down to novelty at the end of the day. We agree that there are standards that exist within the CSA. However, the issue is that there's no system designed to specifically guide an evaluator from point A to point B, especially like in the field itself. So our goal is to kind of to get into the evaluator's brain in itself when they're performing the evaluation, to have a black box methodology where they can begin by doing the checklist items, but then also be able to come up with impacts associated to the non-compliance of certain standards that have already that already exist.
Okay, thank you. Any other questions?
I have a question for Team R, the kite power generator. Have you do you guys have any kind of sensors in your design for like a stronger than a certain wind speed? It may cause danger for the lifter kite to be flying violently, or on the other end, if the wind is too weak, it might just fall down. I don't know. Do you guys have some kind of sensor that tells you what's the safe range of operation for your kite power generator?
Anyone from Team R?
I'll take the question. So what we essentially built is an electromechanical system, and what we're using is we have our spool basically on rails, and it's attached to some springs which we would know the spring constant of, which is connected to a linear voltage divider. So as the spool moves on the rails, the movement of the spool causes the voltage over the voltage divider to change, which is then interpreted by an analog to digital converter on our microcontroller. Using that and some basic mechanical equations, we can actually calculate the tension on the tether. And that's also interpreted by the microcontroller unit to either retract the kite, and it also has a yanking feature as well, just like you mentioned, if the wind speed is too little, and if the kite starts falling down. So if we have too little tension on the tether, we can yank the kite as well in order to assist it to keep flying.
Thank you.
Question for Team AE.
Team AE, okay.
So did you compare your solution with existing ones that are already out there and have been commercialized?
Yes, so my name is Mark Wilson, and to answer your question, actually Babcock and Wilcox, a well-known engineering firm here in Canada too, has their own salt drying facility, but it's mainly meant for salt slushies and slurries with very high saline concentrations. This was kind of the benchmark, and they've created the industry benchmark for desalination, whether it's reverse osmosis or the salt drying method. our specific design, when in comparison, is roughly 1 cent per meter cubed cheaper to generate the water. And the differences between our designs is we were able to take out the dust collection cyclone, which we, through probability analysis realized for irrigation water we didn't need.
So will you be able to convert ocean water into irrigation water as well?
Yeah, so our design was primarily optimized for seawater specifically, to have the 3.5 to 4% salt being present in the inflow water.
So countries like Middle East, they are doing a lot of such projects, and they're using the solutions even to produce drinking water. Have you compared the cost between converting seawater to drinking water? Because as you mentioned in your presentation, that world will have huge shortage of drinking water as well, not just the irrigation water.
Yes.
So
oh, sorry. The traditional reverse osmosis system.
Enhance your project. How challenging will it be to extend this to address creation of drinking water?
So for the traditional reverse osmosis method, which is the primary method used in the Middle East, the cost to process the water, not to create the actual plant itself, that we weren't able to compare yet. The average cost is 28 cents per meter cubed. Ours is 16 cents per meter cubed. And we did this mainly based on energy consumption for our side. Obviously, the reverse osmosis methods are well documented and we're able to get the cost. So we're almost at the halfway mark when it comes to price per liter. And when it comes to scalability and ability to be used in these scenarios, the spray drying method is limited purely by the radial distance of the drying chamber. So you can literally scale up the size of the device in order to increase the amount of throughput that you can, the amount of irrigation water you can generate.
So how are you in your solution to present it to industry to possibly check the viability of commercialization?
So Rajiv, can I come back to this question? I have another question for the rest of the teams. We'll come back to team AE so he can answer the question, if that's okay with you, Mark. So sorry, Rajiv, so there is, so there's some question for team A. From the attendees, from the students, and basically most of the question about Team A project is antimatter physics is the application side. So they need to I think to get better understanding of how they can be applied and what is the advantage of the project and how we can use it for physics lab and how can be it seems very complicated design, how this complicated design can be used or practical enough to be used. So if anyone from Team A.
I can answer regarding the use cases. So one of the biggest applications currently is in the medical field for PET scans. The P in PET scans actually stands for positrons. So the medical profession uses positron emission tomography to inject positrons into a brain and watch for gamma rays that flash when the positrons encounter other electrons of normal matter. So that's one of the big ones right now. A more novel use case is in material science for detecting impurities in materials. They can easily detect impurities in crystals, since an impurity in crystal structure would cause an annihilation to be recorded. So those are two of the big use cases. They're also looking into space travel and how how antimatter can help with that. If anyone else wants to continue from there.
Go ahead.
Sorry, I have just to add on to that. One of the bigger things within this project is that if implemented correctly, we would be able to test space hardware like on Earth and on the ground before it's implemented either on satellites or within CERN, within facilities like CERN or Triumph in Vancouver. And this would then potentially pave way to lowering the cost of space projects like physics projects, space projects, because the biggest thing that we have to take into consideration is whenever something goes out into space is that there's a lot of radiation. And so if we're able to test for that within a controlled facility, that would really lower the cost of the R&D that goes along with these projects. And so that's another space hardware testing is another application that we can physically do right now.
Okay, thank you. Before going back to Team AE, I have a question for Team R, kite generator. So a couple of questions about the at the end the net energy output. So because you are using a motor for your kite, and just wondering is how are you getting the net energy output from your company, from your project? So using power to bring the messenger kite back down. So at the end, what is the output quantification of your power, and how if you can quantify this amount of power, how is that enough to operate how many light bulbs, or how can you actually use this power output?
Yeah, so I will be answering the question. Unfortunately, we weren't able to actually test the entire system, as because of the pandemic, we weren't able to finish the whole system. However, we did some preliminary lab tests, and what we realized is we basically used the same DC generator that we have, and a small issue that we have with the current DC generator, it was just supposed to be a mock-up, but we didn't order the high efficiency DC generator in the end, as it would have been pointless since the system was going to be built anyways. What we ended up doing is we attached 500 grams of mass on a tether and basically used the DC generator to pull it up, and then we let it go. We measured the time it takes for it to move up and down, and also how much power is being used. So with our highly inefficient DC generator that we use for the sake of this experiment, we realized that the power consumption is slightly higher than the power generation. However, we are anticipating that if in the real case, it's actually going to the amount of time, because that was also shown in the experiment as well, the amount of time it takes for the DC generator to pull the kite down, it takes shorter than the kite blowing itself out, which means there's going to be more charge coming in to our battery. So quantification wise, they were pretty close, but unfortunately, since we weren't able to build the entire system, I can't really give a concrete answer on how many light bulbs we can light up. But all I can say is with our math, it shows that we're getting a positive power output, positive net power in the end.
Thank you. Vidushi, I had a question for Team AE.
Yeah, so my question was that in your video, you talk about how the salt that's getting collected is sort of have a flammable restriction. So I was wondering if there's any emergency stopping features or anything that you sort of accommodated into your prototype. And what if something was to go wrong, how quickly can you cool your system down?
There's actually a lot of different ways. Wait, Alec, do you want to say it?
Yeah, if you don't mind. Okay, hi there. So my name is Alec, and we had 2 thermocouples in the system, one at the top of the barrel, one at the bottom of the barrel, and these would be constantly checking the temperature every half a second. So salt becomes explosive only around 255 degrees Celsius when in contact with water. And since we're pouring constant water, it is a concern of ours. So we always have 2 electrical sensors and then 1 analog sensor, which is basically like a barbecue sensor in the middle. So we would always check when the heat gun's on, if it reaches our threshold, and our threshold would be set at 235 degrees Celsius, because near the end of that scale, it becomes harder to reach 255. So we weren't too concerned about explosive salt. And if needed, we would just turn off the heat guns and just pour more water in the system and it would cool it down.
We also had other like cues, like you could see that we have actual lights that would go off when we get close to this temperature. So we would know when this would happen. So like say the temperature does reach above a certain threshold, we would have the light flashing yellow saying yellow, or maybe flashing red saying like we're getting to a dangerous area. And with this warning, the heat guns also have a cooling system. So we don't actually have to put in hot air, we can put in cool air, which actually gets rid of the heat really quickly, because it's really difficult to keep hot air in, but it's really easy to cool it back down, back to a certain temperature that is safe. Yeah, that's what I want to
We also
add.
have emergency e-stop, but we didn't fully set it up because we didn't have much time. But how it worked is we'd have electrical regulator to our system, and if it were to reach a certain wattage, we could shut down our system remotely or manually. So we could tie this in with our code we wrote in Python to reach a certain temperature, 255 or 225, and it would automatically shut down all our heat guns. And we had an LED light as well, which would flash red, and that would tell us to know to like start the cooling process as well. So we had a lot of safety measures in place.
Okay, thank you. Any other questions?
Yeah, I had a question.
Roger?
Following up with the water guys again. So what kind of efficiencies were you able to achieve? So your water in versus purified water out with your system? Were you getting 100% conversion? So that one's a little harder to measure. So what's happening is as we're spraying the salt water into the system, most of the water is leaving, but it's kind of like a powder salt slurry that we get at the bottom. It isn't completely dry. If we were to just assume that our system was as efficient as the Babcock and Wilcox version, then there's roughly 3 to 4% water content still in that dried powder that's at the bottom. But we were not able to measure that ourselves. How did you plan on measuring that? Because it's kind of essential for your calculating your efficiency and your cost per meter cubed, right?
I can answer that.
Yeah.
The way we were planning to measure that is we would have a fixed amount of liters that actually go into the system, and we would check the liters going out of the system and how much powder we actually had waste. So you can measure the grams of salt that's like left at the bottom, and we were also able, you can also able to measure the input water and the output water, and you would deduce it based off that. So we would have 3 sources to check it from.
And then the other you thing to have- be noted is we're using a saltwater simulant. So we're adding salt to the water, so we know exactly how much salt would be present. And from that, we also know how much salt should come out of the system too. It's not an unknown number.
Any other questions? So I have a question from one of the students to team X. Let me read the questions here. I think the question was, I think the student was confused about, is your project or your product is a set of instruction how to generate a survey, or it's actually the survey? Because he said that he's supposed to provide instruction for generating survey, but in the actual video, it seems UMTS is the actual survey. So if you can just elaborate on that in that point a little.
I can take this one. It's the set of instructions. The video is to demonstrate how the set of instructions could be used as an example platform, because we figured that would be more interesting than just watching someone going through a set of instructions.
Okay. Thank you. Any other questions?
I had a question for Team A. You guys mentioned space hardware testing as one of the use cases for your project. So having having the need to protect electronics from radiation, what safety mechanisms have you guys implemented into your own design for the electronics that actually sample the number of annihilations and make those measurements and protect them from the radiation that your experiments generating?
So at this current time, we unfortunately haven't been able to implement much, but we were planning to have multiple, well, we were thinking either we could have multiple computers to do the processing or separate locations in memory so that we could have like a redundancy on the actual software itself. So if there was like a bit flip in one area in memory, it wouldn't affect the other area. So this is what we were trying to implement to protect against the radiation. And we had a design for it, but unfortunately at this time it wasn't able to be implemented. But we do want to add other redundancies that are hardware as well. So maybe a second computer so that if something does occur that damages one computer, the other computer can still do the computations, especially for the emergency stopping mechanism. This is really important to keep our turbomolecular pump safe. And it's actually not very expensive to add another computer because we're using Raspberry Pis. So it would only be like a really small cost to do this.
Thank you. Any other questions?
I got a question, Hossam, for the kite generator group. Did you guys put any thought to the design of the kite? Like it probably needs to go up real fast so it can generate a lot of voltage, right? Did you guys put any thought to the design of the kite?
So yeah, so our kite selections, we made it based off of what each different kite would be able to do. So our kite that actually generates the power is one that is able to move very fast within the wind. So we would move up and down a lot faster than our other kite, which is just a kite that flies stably. So yeah, we did take that into account, and our kite designs reflect that.
Okay, thank you.
Any other questions? Okay, I have a question for the kite generator is I'm just reflecting on wind turbines or any other renewable energy source. There is a lot of people examine the impact of the environment. So if you have a kite and they might have an impact on environment or some safety procedure, you have to make sure that you are not impacting anything on the environment. Did you consider that? Like if someone want to create that, what other thing that he need to be aware of?
Well, I'll take the question. So the most obvious thing is that we need to take into account is that things are around it. So for example, when you're flying a kite, you can't fly it around an airport. You can't fly it when you have when you have power lines around. So those sorts of environmental factors we have to take into account, but we should also take into account that this what our design was is primarily for small scale operations, so it wouldn't really have too much impact on a larger scale. It's like using a small wind generator on your own house rather than using a full-on wind turbine that can actually like affect animals. But we did take that into account so that we know there are regulations and limitations when it comes to where you can actually implement this or not.
Okay, and will if the wind was there is some hard materials in the wind, or like derbies and stuff like that, will that affect the performance of the kite or destroy the kite? Is there is any concern about let's say the safety of the product itself against external environment?
Could you repeat the question, please? I missed the first part.
So if in a windy environment, when you are working with your generator, and let's say the wind is there is some stones or something flying with the wind that might actually destroy your kite generator, is there have any protection procedure to protect the kite from being destroyed by the wind?
So when we are flying our kite, currently our small scale design is only going up to about 100 meters. We did try to choose a kite. Currently, our lifter kite, which is flying up very high and stable, is ultrafoil. That isn't the best against maybe stones going up in the air, We originally only tried to choose in our kite design to try to choose a kite that could handle maybe some more extreme wind speeds. We didn't, since it's so high up in the air, we didn't feel the need at the time to account for things like stones being thrown at it or other things like that. We did, however, think about smaller dust particles, but we didn't believe that smaller dust particles or things like that could have a serious impact on the performance.
Okay, thank you very much. Just for the sake of time, I would like to thank everyone who participated in this panel. That's actually was a great presentation and great questions and great answers. And at this point, for panel 7, if everyone, I am hoping everyone raised their hand, they're already ready to go. And then Franz can take charge of panel 7. Franz.
Thank you very much, Hassam. So on to panel 7. In this panel, we have the arm and leg robotics team. No, my apologies. The all-purpose modular base team, who's designed a base for multiple medical and non-medical purposes. The EEG headset for neurorehabilitation team. And we have 2 teams looking at solutions for addressing lung health in rural communities. The first is a portable lung health assessment unit, and the second is a ventilation solution for indoor smoke. So if we have the video lined up for these 4 teams, we can kick that off.
We are Team B, and our project is an all-purpose modular base. Our project is to design, manufacture, and assemble a versatile, personalized, and economical multi-purpose base that can be used in the medical industry. This project will meet consumer needs by creating a modular base using an interface attachment system to accommodate varying upper attachment modules. For the scope of this project, however, we will only be designing and creating the lower module and its interface connecting piece.
The product is aimed towards facilitating procedures done by medical practitioners. Therefore, the product should be able to be connected to upper modules that are relevant in the field. For example, the upper attachment could be an overbed table or a blood pressure device, or it could be a holder for ECG machines, a baby incubator, or an electrosurgical unit. It could be connected to a nebulizer or an anesthesia machine. It could even be used to hold an oxygen carrier or as a stand for surgical lights. The product has a number of possibilities as to what it could be connected to. It is up to the user for how they want to ease their procedures.
We were tasked to create a wireless headset which uses dry EEG electrodes to transmit brain activity to computers for neuro rehab purposes using a printed circuit board and Bluetooth chip. The challenge here is to use dry electrodes for this purpose, which are usually less reliable but more convenient, and to make an efficient circuit that can transmit signals for several hours without being tethered. The headset frame needs to house the electronics and secure the electrodes to the user's scalp. After several failed attempts, the latest iteration was able to sit securely on the head with an elastic band in the front for flexibility.
Through months of research, we were able to choose electronic components that met requirements of developing a medical-grade PCB. Previously, our client's PCB was capable of supporting only 8 channels, whereas our new design now supports up to 16 channels. Our design and choice of hardware significantly boosted the signal-to-noise ratio and limited the noise. And our design became completely wireless, incorporating Bluetooth 5 technology to transmit the captured data.
Good day, everyone. We are Team Y presenting our new lung health monitoring device. This hut, built without windows or chimneys, traps the smoke inside. This affects the lungs of the people living inside of it. The solution? An affordable portable means to determine the health of lungs, particularly of people with breathing difficulties due to living with these pollutions or diseases. The main stakeholders for this project includes the people in rural areas, researchers and doctors assessing the respiratory health of people living in such rural places, the Lassonde School of Engineering, and the industry that designs portable spirometer. Our design has undergone many changes. Here are 2 of our highly debated designs: to handle or not to handle, To answer this question, we conducted a simulated drop test as to not damage our device to measure its structural integrity, which leads us to our final product, a colorful CAD model. The green handle attaches to the battery case, the circuit housing, as well as the Venturi tube situated at the top, to which our disposable mouthpieces attaches at one end.
Team AC ventilation solution. The problem we are faced with is the burning of solid fuel creates a heavy plume of smoke that accumulates inside the huts. With no ventilation, women and children are exposed to large amounts of indoor air pollution, which subsequently causes significant respiratory problems. An example of this can be seen here. The problem statement our team came up with is to develop a solution to reduce long-term exposure to smoke in order to combat adverse health effects in rural Ethiopian communities. Trade studies were conducted to shortlist the most effective solution, which considered extraction rate, cost, complexity, and mass. The turbine and wall flap solution we chose is cheap, simple, non-intrusive, and requires minimal input. Our results showed that our system extracts smoke in both wind and no wind conditions, and performs significantly better with this flap open. We hope this can positively benefit rural Ethiopia. Thanks for listening.
Thanks for those videos from Group 7. So I'm going to start the ball rolling with a question. Obviously, all of these projects are somewhat health related. So I'd like to start with you thinking about how did you take into account requirements around health or knowledge of health information in your project? And if I could start with Team M on that, EEG headset.
Yes. So how did we address health requirements?
Yeah.
Right. For our project, I think the two main concerns was, since it's a headset, the material that we use for the actual headset and the wireless components of the materials. So as for since we're making a prototype where we went with 3D material, 3D print like ABS plastic. So it doesn't represent the final product, but it should be safe to use for prototype purposes. And since we're using standard components for the wireless devices, they've already been approved. We haven't done anything new there. We just assembled the PCB using those components, so there shouldn't be any concern. And then for the battery heat, that might cause discomfort to the user, but we couldn't do actual testing, but we did a test in SolidWorks and it should be comfortable.
Okay, great, thank you. If the same question could go to Team Y, the lung health assessment.
Pardon me, could you please repeat the question?
Yes, Joseph. So the question was, how did you take into account health requirements or knowledge? Obviously for yours, you were developing a device that was measuring health capacity. So how did you get that knowledge in?
Okay, introduction. My name is Joseph Paris. The main sources, we relied on existing data provided by existing devices, and we got them off of the internet and a few hospital websites, health websites that were conducting tests on how the typical healthy capacities and performance of lungs are for a range of people, like of different ranges of ages. And using that data, we try to recreate using our sensors, if that answers your question.
Yep, thanks, Joseph. Okay.
Could I also add on to that?
Yeah, please.
So for our portable lung health device, we're creating something where the user has to put their mouth on. So contamination of bacteria and germs is prevalent. So what we decided to do is use a disposable mouthpiece to help remove those germs, as well as clean the product with disinfectant after it's used.
Thanks, Daniel. Very important clarification, especially in current times. So appreciate that. So if we could have a response maybe from Team B for the all-purpose modular base.
Maybe I could answer some of that. My name is Murti Patel. So we noticed that during in hospital uses, we found that the beds are mostly automated and they're more comfortable. However, we found that there was a need for the medical equipment to it's not as customizable. And so based on that, we tried to make medical equipment that could be customizable to the patient's needs. And for safety needs, we tried to follow reports such as TSA, Canadian Medical Device Regulation, and the Canadian Electrical Code to make sure our device was safe for the patients.
Yep, thank you, Murti. And finally, the ventilation solution for indoor smoke. So in what way were you taking into account the medical advice around quantity of pollution and how you remove it?
Hi, so I'm Mohammed Qureshi, and basically how we approached this was since our problem was mainly respiratory, so we looked at indoor air quality guidelines for the specific demographic we were given. But since there were none that were defined, we just took the World Health Organization guidelines for indoor air quality, and there was no specific values that were given to us, so we took into account that any reduction in harmful particulates in the air would be an improvement for the health requirements.
Okay, thanks, Mohammed. Okay, so I'd like to open up the questions to the judges.
So I have a question for Team B.
Yep,
So the you guys have a separate like interface to be able to attach different objects. So would that interface need to be attached to each individual component that you want to be attached to your base? And then what is the health consideration that you for having like a nurse, for example, having to lift whatever component onto the base and attach it?
Yeah, I can try answering that question. Sorry, what was the first part?
So the first part was, do you have to attach the attachment
okay.
to each device?
Yeah, so on the base, there is a male end of the interface, and then on the upper module is a female end, and so the female end must be attached to every single upper attachment module, and so the nurse would have to carry the upper attachment and place it on top of the base. And there are health concerns, but however, we don't expect there to be significant ones. For example, an upper attachment example could be like an overbed table, and those are not as heavy, and so it wouldn't pose too much health concerns to the medical team putting it on.
Thanks, Murti. We have a question from the attendees around for the lung health assessment team, Team Y. Can you discuss the electronics of the device? So you mentioned you have a Venturi tube, but how do you translate what's happening with the Venturi tube into a diagnosis, and how does the tester get the results?
Okay, so the main component for us that we used was a pressure sensor. And what we're doing is we're calculating the differential pressure between two areas of the Venturi flow meter. And we're taking like the inlet and the middle portion, and using the Bernoulli's equation, we're able to calculate the volumetric flow rate and also the velocity flow rate. And we're storing this data. The main component which we're using is a Arduino Nano, which is connected to the pressure sensor, and also a micro SD card where we're saving that data, which can be extracted and read onto like a computer through a text file, or even plot graphs over a certain period of time on Excel.
Okay, thanks, Daniel. We have a question from one of our judges for Team AC, the ventilation solution, Vidushi.
Yeah, so my question is just based on the summary slide and also your actual presentation. You're sort of directing your prototype for huts in Ethiopia, and just considering the way they're constructed and what your prototype looked like, it's sort of hard to correlate how you plan to implement that into the homes. So how would you like mount them to those houses? Have you thought about that?
Hi, Vidushi. I'll answer this question for you. So the huts are mostly made of, the walls of the huts are made of clay, and the roofs are made of straw and a mixture of, it's also, it varies from hut to hut. So it can also include mixtures of clay as well. So of course we have to make some holes in the house and in order to mount our device. A requirement initially was to, by the customer, which was the Technion Institute, that we need to make least possible amount of changes to the living conditions or the conditions that they're working in. So we came up with a solution which requires only requires to make only two, well, I would say not too big of a holes, but we only, so for one hole, but which we'll make is would be a window for cross ventilation, and the second one would be to mount a turbine on top of it, on top of the hut. And those turbines, we also accounted for weight requirements. Those roofs cannot take a lot of weight, so we also came up with a solution which would not be loading the roof unnecessarily, or to a point which would make it unsafe to live inside the hut. So, yeah. So and the mounting solutions for both of the both of the components of the hut. The first component is the turbine itself. Just gets mounted on top of the roof with some tech screws, which are what do you call it? Self-tapping screws, which can go easily inside and do not require any assistance or any sort of nuts on the other side in order to get mounted. And the other component of our design is the flap, the wall flap, or it's basically a hole in the wall, a square hole, and it can be covered with either with a cloth, or we also provided the details in our report to make a cover for it, how in-house, so that it doesn't increase the cost of the project.
Thanks, Taha. Another question from our judges. I think Louis, you might have wanted to jump in.
I think he might have answered some of my questions about the ventilation. Just to be 100% clear, your design does not require any power for the ventilation system, right?
So what our design, the way it works is basically a turbine ventilator. It's in layman terms, it's called a whirlybird. It's a rotating turbine on top of the. You can see it mostly in North American houses, which have problems with attic ventilation. They just work with the help of the wind. No external power is required for that.
Okay,
and for just to add one more thing, we noticed that if there is no wind in the area, so the turbine really stops moving, or not really stops moving, but I would say the extraction rates goes down. So that's why we added a wall opening, which could increase the extraction rate because it promotes the cross ventilation.
Okay, thanks for that. Any other questions from our judges?
I've got a question for Team AC, the ventilation system, if I may. So what are the advantages of your system compared to a traditional chimney? Yeah.
So we basically,
your answer concise, that would be appreciated. Thank you.
Sure. So we basically came up with 3 designs, in which one was a chimney as well. But the problem with chimney is we don't get as much of an extraction rate, which we think would be required to evacuate the room from the smoke completely in the shortest amount of time.
Can I add on to that as well?
Quickly, yep.
Yeah, so one other problem that we were facing was the stove that they actually use to cook on is not really placed in the same area inside the huts. So it varies from each hut to hut. Sometimes it's placed in the center, sometimes it's placed in a corner. So we can't really create a standard chimney location for all of the huts put together, which is why we decided to opt for this option.
Great, thank you very much. I'm going to jump in with another question. So because a lot of your projects are related to health requirements, and there is the potential for an immediate risk to humans if the product fails. So in what way did you look at the risks that your product could pose your end users? So if we could start with Team B.
Sure. So some of the risks that poses to our patients, we were very aware that since our machine is it's very mechanical, we would try to we would implement safety features to prevent human contact with the moving parts, to prevent, let's say, like a skin getting jammed in between, or like clothing getting caught in between. Also, we plan on making the electrical wiring very insulated to prevent any like short circuiting or anything occurs from there.
Yeah, thanks, Marity. If we could have the same from the EEG headset team.
Discomfort from the headset, discomfort from heat, any potential exposing to electrical wires, but we tried to address all of those as best as we could.
Okay, and of course the other thing being your signals are then used by a second system, and you have to improve the quality of the signals. So. Yeah, okay. Thank you very much. If we could go to Team Y.
I can answer that question. And so for the portable lung health device, the errors that we may encounter are corrupt data, inconclusive data, infection, or lack of sanitization. The device itself getting short-circuited and getting damaged, and might harm someone else. I'd say those are the main things.
And how did you tackle them?
And so for sanitization, like was previously mentioned, that as well as a disposable mouthpiece. And for corrupt data, we're basically trying to develop the software or the code and make sure that there's always a backup for how it's transferred to a text file, and make sure that data is stored well and documented well by the actual technicians in the village. And so that way they know that they know which patient and which data, and they can have something more conclusive to work on.
Also for the electronics, we also made sure that there was a casing around it, which can be protected and easily accessible if there was any issues that needed to be fixed.
Okay, thanks, Daniel. And finally, the ventilation team, AC.
Yes, I'll take that question. So in our project, the redundancy is the wall flap. So if the wind speeds are low, the tenants can use the wall flap and the ventilation system will work.
Can I just add on to that? With the system risks to the user, there are essentially the system doesn't pose any risk to the user because it is first of all mounted on top of the roof, and the only moving part is outside the system itself, which is the hut. So the users won't get affected or get harmed by any of the actions. So
I was thinking more about the case where the system itself got blocked and therefore failed in its main purpose. But I think you've tackled that through previous answers. Okay, so we do have a question from the attendees, but before I go to that, are there other questions from the judges?
I have one.
Yep, go for it, Peter.
So this is kind of a question for both teams Y and AC. So it sounds like you're tackling the same problem, but team Y is tackling the part where you're really assessing and identifying the issue, whereas team AC is tackling solutioning once you know where the problems are. So I was wondering if both teams have put any thought into helping or figuring out how you would market your products when considering solving the global issue. So perhaps maybe team Y could answer first.
Yep, go for it. Thanks. Thanks, Peter.
So for our device, it's mainly for the lab technicians there in Melkele that are going to use it. And they'll generally take 2 or 3 days to visit a few villages. And in each village, they'll assess maybe 20 patients. And so in the reason that they're actually having a poor lung health is because of their communal activities within each hut. And so I think in terms of marketing, we can potentially market to these technicians and labs elsewhere, as well as in Melkele, as a target audience. But also we could use it as a way to target lung health assessment just in general, because it is a device that is targeted for lung elasticity. And so essentially, I guess in some way, the strength of someone's lungs. And that way we can, that's useful anywhere, I think. And so we'd be able to market it that way. But I don't know if that answers your question. Sorry.
Yeah, thanks, Peter. If we can go on to AC, same question.
Yeah, hi, Peter. So with Team AC, we kind of have an advantage of application all around the globe with our project because first of all, it's a really cheap solution, and the problem is not just found in Ethiopia; it could be found in rural areas of any underdeveloped or third world countries. So it could include any countries from South Asia. So this and the population is significantly larger over there as well, and the population living in the rural areas is also larger over there. So that's why this solution can be implemented in I would say worldwide in the rural areas.
Great, thanks. Okay, we've probably got time for one final question. If there's nothing urgent coming from the judges. Did you want to follow up at all, Peter, or you're good?
I'm good.
Yeah, okay, thanks. The one question that we had from the audience that didn't get asked was, Capstone is a big undertaking, as I'm sure you're aware, especially this year with the interesting circumstances. And a number of you have had interesting twists and turns in your project, pivots and so on and so forth. What would you say is the biggest takeaway that you have from the pivots that you've made? So if I could ask that to Team M, EEG.
Yeah, so I could answer that question. So hi, my name is Danilo, and pretty much the biggest turning point in our project was when one of our members actually could not continue the course anymore. So that was something that we weren't really anticipating for, and that member was responsible for the GUI, which would represent our data in a pretty presentable manner that would allow you to actually see the outcome of our project. And since we weren't really planning for that, we didn't really have much of a GUI at the end. So it's always good to take a good risk assessment in that case, in case any of the members might not be able to continue in the project.
Thanks, Danilo. Great. If the rest of you could keep your answers really concise, that'd be great. No criticism of you, Danilo, at all. Team B, you've had a few pivots during your project. I wonder if you could just say what your biggest takeaway is.
Yeah, I can take that. So the biggest pivot we had was when we had to change basically the basis of our project when our client decided they cannot continue with us. And what we've learned from that is that the communication really depends on the client. You can't just have the same type of communication with your supervisor, your teammates, or your client. Like sometimes you have to, it's not sufficient to just let them know. Different types of client require constant or reassurance and communication, or else you guys are never going to like have the same vision for the project. But, yeah.
Thanks, Aya. Team Y, maybe a couple of words. Anybody from Team Y?
Biggest takeaway would be that despite whatever issues you face, you can always find a turnaround and problem solve as you go. And asking for help is always a good thing, even if it's really for dumb questions.
No such thing. Yeah, thanks, Joseph. And finally, Team AC, quickly.
So I'll take that question. So I think our biggest takeaway was to maintain proper communication with the team members and the supervisors. And like without that, everything would really fall apart. And thank God, like we did it in our project as well, so everything went smoothly.
Great, thanks again, Sad. So that is the end of panel 7. Thanks again to panel 7, that was really good. And we're on to our last panel, panel 8, and I will hand off to James to get panel 8 going.
Thank you, Franz. Thank you, panel 7. And for those of you on panel 8, if you'd like to raise your hands to be to the list of panelists. We have, we're now ready for just about for the video. So if we want to queue up that video, that'd be fantastic. I just want to say a quick word, a grateful word to all of the staff who are not just helping, but running this today. It's not just helping, it's making this happen. I know that that a lot of students and people that are watching this don't see the staff as much because they're often behind the scenes, but without them, this would never have happened. So a big thank you. And you know what? And a huge thank you to Franz as well for having the determination to make this happen as well. I think that that's, I didn't know that this would be possible to do. And this has been a far better experience than I was thinking it could be. This has been really, really good. Thank you, everyone. Thank you, Franz. Thank you to the staff for making this happen. And thank you for the students for persevering with your projects. All right, I'm being shown. Anyway, next we have a video.
LM Red was contracted by Lassonde Motorsports, York-U's FSAE team, to develop a chassis model and a proof of concept suspension assembly for the LMP1, their first competition vehicle slated for a 2021 release at Formula North. The plan was to validate and build a proof of concept system with a budget of $1,500, approximately 12% of the estimated part cost of an actual complete FSAE chassis and suspension system. Here we see the front section of the chassis. This is what the team was going to build for LM. Both the front and rear systems use a double wishbone design. Our design provides the required ground clearance during static loading and a full range of motion for dynamic events. From a top-down view, we can see that the front suspension system on the right of the image is almost completely vertical, where the rear suspension system at the left of the image has to have a custom angle design incorporated in order to account for the engine. Both chassis models passed all testing procedures that were performed during simulation.
The steering system is divided into two parts for the ease of designing. The first part includes the components going from the steering wheel to the rack and pinion, and the second part includes components going from the rack and pinion to the wheels. Here we have the first part of the entire steering system assembly with all the different components. It is designed with 12 different components, which include the connector that attaches the steering column assembly to the chassis via the quick release connector, which slides into the quick disconnect. Here we have an exploded view of the second part of the steering system, which is the rack and pinion going all the way to the knuckles where the wheels will be mounted.
The model shown here is a model for the full chassis. The team has decided to use a 1.375-inch outer diameter and 0.095-inch wall thickness for most of the model. This includes everything except for 4 members of the fully welded chassis. Those members are using a 1-inch outer diameter with a 0.095-inch thick wall thickness.
My name is Ramil Kachel, Team Lead for Human Powered Vehicle Team N. In the beginning, the group set out to build an HPV. We wanted to build something that focused on user safety and user comfort, but also something that represented the future, something that was out there and different. And that's what we have for you here today. Behind me is a hybrid electric human-powered vehicle. The vehicle has many features. For example, it has motor assist, enhanced nighttime visibility, user adjustability, and so much more. And it's also a vehicle that we've been working on, that we put our time and effort into building. The project had many ups and downs. There's many highs and there's lows. But today I'm proud to present to you the project that we've been working on over the last few months here in this very garage. Introducing the Triance E3.
We are Team O, and our project's the fabrication of a hand cycle. We'll start off by showing you a 3D rendered of our CAD model of our final design. Here you can see our hand cycle in its full glory.
So the purpose of our project is to use the ASME standards to create a competitive hand cycle for paraplegic users interested in recreational activities.
Primary stakeholders are our team, and the secondary stakeholders are outside of the others. For example, paraplegics, our Professor Hansen, and also people who wants to do any recreational things using this bike.
To meet requirements, we incorporated all the necessary safety protocols needed by ASME. These involve the seatbelt, brakes, and the rollover frame in case for collisions. In addition, we also incorporated an adjustable seat in order to accommodate for our dimensions. In addition, we have also included a footrest with straps and to accommodate foot paraplegics who will not be, so that their feet will be protected.
There we go. Thank you very much. Those lovely videos. Would anybody like to open with a question? Rajiv, am I seeing Rajiv there? Or... Nope. Okay.
I have a question for Team N for HPV.
Yeah.
In your design, first of all, it looks really impressive. That looks like a really modern HPV bike, which I would buy. But the only thing I did not see in that design was safety features like the other team was talking about. For example, the ASME or HPVC competition has some strict guidelines about safety belts and the rollover bar, which are pretty critical. Is that something that you guys are gonna still design, or is that something that was left out for reasons known to you?
Hello, can you hear me?
Yep.
So in the original design, we actually designed it with a frame, an external frame to protect the user. But due to the situation that's happening right now around the world, we weren't able to get the materials that we needed to complete that part of the project. But we added other safety features to kind of make up for it in the end. And I hope that kind of answers your question.
Yeah, just a really good job on that bike. That looks really good.
Yeah, great project. Question I have is two or possibly three questions. Did you look at maximum speed? What is maximum speed achievable in this vehicle?
Hello?
Yeah.
Yes. So by law, we kind of had to adhere to the e-bike regulations of Ontario. The motor will only help you up to 32 kilometers an hour, after which the program automatically cuts it off and it won't assist you any longer. So our maximum speed would be 32 kilometers an hour just to meet regulations.
I'm going to interrupt there. If you were in a closed track, how fast could you go?
We haven't looked into that specifically just because we weren't able to stress test it that fast. But we have gone up to around like 30 just by testing it outside.
I have a feeling the York track could be used in social isolation mode for a test if you really need to. Anyway, I'll let Chief continue.
What
Chief,
about
would you like to continue?
Yeah. I was asking consideration for braking distance. If you're sort of driving with 32 kilometers per hour speed, suddenly you see an object in front of you, how do you brake in the shortest time and going forward within certain distance?
So the vehicle has 3 brakes on it. It has 2 front brakes that are controlled using the left handle. And it has 1 rear brake, which is controlled using the right handle. In our testing, we went up to 25 kilometers an hour. This was a recent test. And we went up to 25 kilometers an hour and we braked within around 3 to 5 feet. Since we put 100% brake power.
Okay, good. And being a 3-wheeler, can you drive it on the sidewalks or you'll only drive on the road? Did you get that?
You did on the sidewalk, but it's like not recommended. We did this. You can.
So could we hear a repeat to the question, or is it nothing about driving?
The question is, what is the maximum width of this vehicle? Will it drive?
Sure. The maximum width of the vehicle is, I believe, around 85 centimeters.
Okay.
Thank you.
I have a question also for Team M, because first of all, great job. I love the vehicle. It looks fantastic. But because you have a motor assisting with the vehicle, I assume it's powered by batteries. Have you thought about using the braking power or some kind of mechanism to recharge the batteries from the brakes, or is it how do you charge your batteries?
Can I talk about that?
Sure.
Yeah. We were actually thinking we should implement regenerative braking. That was an idea. However, we are all mechanical engineers and we don't know too much about electricity. So in that case, we kind of left regenerative braking out, but maybe if we were to continue developing this product, it would eventually get to regenerative braking, and that would be great.
For the braking, we will also put on a constraint with the budget. So in future possibilities, if we had a higher budget, we could potentially look into gaining material that would help us develop regenerative braking.
Okay, thank you. Sounds like something we should be adding to the curriculum.
Right.
All right. Any other questions?
I got a question.
Yes.
So this one's for team C and D. I was wondering if you guys can speak a bit about the novelty of your subsystems as compared to the other FSAE subsystems that are already out there.
Would somebody like to field the answer to that?
Sure, I can take a stab at that one, Dr. Smith. So thanks for the question.
one of the bigger problems is we're kind of like late to the start of SAE. It's been around for a very long time, so teams have developed a lot of systems already. They've already put a lot of years and time and money into developing these systems, whereas we're starting from scratch. So yes, we did look at what they've already done, and we tried to find ways to do it differently in our way. But it is quite hard, as you say, to change these subsystems simply because this is something that has been around and it's almost been perfected. I wouldn't say it is perfected, but it's very, very close. So while we did mimic a lot of the subsystems that exists, currently there's not too much of a difference between us and the other FSAE teams, largely due to the restrictions that we have through the FSAE regulations. And then just, as has been mentioned many times, budgets is a big problem as well.
The reality of budget constraints is difficult for most projects, I think. All right. Any other questions?
I got a question for the FSAE chassis team. Now, the chassis, it looks pretty good, but first of all, what kind of materials you're using, and was it like the most optimized design you guys could come with? Because it looks like it's got a lot of weight on it.
So the chassis is pretty heavy right now. We're using 1020 steel throughout, mostly because of budgetary requirements. It's the cheapest we can use for safety. Currently, the team is missing a lot of interface requirements, so things are slightly oversized and maybe too many components, especially with regards to triangulation. So once we know more about our drivetrain, our engine mounting, our fuel tank, and as those components come into place, the chassis will be continually optimized to shed weight. So the entire model as it stands has been parametrically modeled with a set of governing values. And as you update the values in those, the interfaces increase and the model optimizes itself.
Okay.
There was a question in the session. I'll read it out, and it's targeted at the FSA teams, so the formula teams. How did your design manage the human component of the chassis for safety? Oh, and hold on. The question just disappeared. Here, I'll try it again. Sorry about that. Question for the formula team. How did your design manage the human component of the chassis for safety and driver comfort while remaining efficient with material use?
So our client, Lassonde Motorsports, has built 5 different versions of an ergonomic rig throughout its years and has come up with certain positions. In addition to that, there's a model known as Percy available in the FSA rules, which outline the estimated 95th percentile male. We made a secondary model for the 5th percentile female and arranged the driver accordingly to make sure that there were no hard angles to be found. Again, this is all gonna dependent on change based on how the seat is designed, any material selection made there.
Okay, thank you. All right.
I'd just like to add on to the fact, to the question for human comfort. We also have a adjustable steering system as well, so that it can account for, as Ariman had mentioned, the 95th percentile male and female ratio.
Okay, so adjustable steering system, excellent. Okay, are there further questions?
I've got a question for Team N. You're using a battery for your vehicle. Are you encasing it in any metal cage to protect for like safety reasons?
At the moment, it doesn't have a casing around it. That's just because that due to the situation that's happening right now, we actually expected to use a lithium-ion battery with different dimensions, but just recently we were kind of forced to buy SLA batteries. So we weren't able to manufacture the thing just because we didn't have the part until yesterday. So that's kind of unfortunate, but we make the best out of it, right?
So an SLE battery is basically a lead acid battery, yes?
Yep.
Yeah, so it's a lot heavier than lithium ion.
Yes, it is. We were supposed to use lithium ion, but that was the only thing we could find that was available right now.
Well, it does have the advantage of not catching fire lithium ions do.
Yes, yes, that too.
Yes. So safety consideration, more weight, more safety. Okay.
Just to further add on to that answer, initially our design did have a casing around the battery, but as mentioned earlier, the battery couldn't come like to us in time. So we kind of just had to go with whatever we had on hand just to see if the integration of the system works or not. And this was a good, basically, indication that the integration that we did is perfectly functioning.
Yes. Excellent. I think this is a common theme that we're hearing is a requirement to adapt to the situation that you find yourself in. Speaks to the capabilities of our teams and our students.
This next question is actually more out of curiosity for Team N, because I like the look of the vehicle so much. What's the cost of building something like that? Like, would you say it's commercially viable to build something that's still affordable by the masses, or is it only for the elite few?
So when we tried to build everything together, after all the prototyping and designing, it costs around $1,500 to build. That's without the final battery, of course. Now, let's say we put this in a market, it would probably be a lot cheaper, just because of mass production. But we actually did a business analysis, and I think one of my team members could go further into that.
I think what Louis is trying to say is that you have to buy one.
So I think in terms of the production cost, well, with our case, our team was quite lucky because we found a lot of like old bicycles, and then we had to be innovative and resourceful with the parts we got. So we did a lot of machining and a lot of modifications to those bicycles, and further like brainstorming on how to integrate them into what we have right now. But I would say in terms of, if you were talking about mass production, the components that we used were not that complicated. They were pretty simple. Like the geometry also that we used was would be simple if it was a mass production scenario. So I think the cost to produce it would be significantly like cheaper than what we built right now.
And just to add on, most of the parts we use are off the shelf. So if we go into mass production, we would go into further designing our own parts and making our own designs for each individual component. And I think that might reduce the cost overall too.
Excellent.
Can I also add on that this is supposed to be more like in between a bike and an actual car. So the price range is actually pretty low in terms of actual vehicle, which is what the product should be.
Excellent, thank you. All right, does anybody have further questions?
So I have a clarification question. So I was wondering if you actually tested it on running on the battery itself, or just the bike component is working for now, or the manual component?
The entire vehicle was fully tested with the electrical system running. We've done it a bunch of times already, and it's fully tested and it's working.
If it's meant to be somewhere between a bicycle and a car, maybe you should think about putting a space for carrying some cargo. just joking.
If you actually look at the design, the mud guard, you can kind of see it right behind me. It acts like a little rack, where you can actually like hook stuff on to the little rack, or you can actually strap things on top of the rack. That was one of our design requirements. I mean, that's why we put it in.
Excellent. Do we have any further questions, say for the formula teams?
I have one.
Yep.
How would you protect the rider from rain or snow?
Again, these were some considerations that the team decided would be our future, like, our future modifications. Like with the budget we had, and I guess the circumstances we're in right now, the scope like kind of really narrowed for our team. So we kind of basically focused more on the completion of this project. Like we had a lot of ideas in our mind before, the whole situation with the pandemic occurred. Like we were thinking of having a fairing also attached to it, but then we had to as the situation was really fluid with the COVID-19, so the group had to make decisions on the fly. So we decided to cut off a bunch of ideas that we initially had planned for this year.
So last question from me. Are you planning to commercialize your design?
Why not?
Not ready yet.
It's basically ready. A few more tweaks, let's say another month of working or a couple of weeks of working, and we're confident of bringing it outside.
Great, good luck.
For the formula team or teams, we have an open question right now. First was a compliment on a great job, but second, please let them, the teams, explain the obstacles that have not yet been resolved, and secondly, to be specific, what their plan is on continuation. Because often with these formula teams, they are multi-year teams or multi-year projects, and they get passed on to different students. Students take them on for multiple years. So would either of the formula teams like to?
So I could take this question as for the chassis as well as the steering team. So a really big challenge that we faced along the way was for the chassis to be welded properly. We do not currently have a welder on the team. We were able to find a first-year student at Lassonde that did have his welding ticket. And right the day the pandemic was issued, we were able to get a sample welded, and it was really well done. We were really satisfied with it. We showed it to the client. They seemed to be satisfied with it. The plan was to go on and get it done with the 1020 steel tubing. However, we were not able to get to that stage. The biggest challenge was welding manufacturing stage, to answer that question.
Okay. Did anybody want to continue fielding that question?
So to add on to that, I think Isaac and Andy can answer specifics about the suspension system, and then we can circle back to what the next stages are for the project as a whole.
Yeah, okay. So from a suspension side, because there's so much still unknown about the vehicle, such as a lot of the weights are unknown and where the center of mass will be and the actual speeds that we'll be able to hit, a lot of the important parameters that'll affect performance are kind of estimated in our design, which is an obstacle we faced. And then moving forward in the team, as they continue to refine the design down and get more concrete ideas of what the speed and weight will be, they'll be able to tune the suspension up. And ideally, our suspension system that we've designed is easily modifiable for them to adjust it accordingly to the different changes that's going to come.
Ashish, do you want to jump in about the steering system and what's remaining or what's next?
I can actually talk about the steering system and add on to that. Originally, the steering system was supposed to have a tilt and telescopic function to accommodate all kinds of driver sizes that we would encounter in a typical racing. As we went ahead in the project, we realized that in the telescopic function does not really fit in the scope of the project due to budget constraints, not being able to find the right parts, not having enough time on our hands to design everything according to the constraints and abiding to the rule book itself. So it had to be unfortunately taken out of the scope. So we just stick to the tilt function in the end and not having the telescopic function at all.
So circling back, the biggest point that's an issue for both teams right now is LM doesn't have a concrete knuckle design yet or an idea of one. So using the suspension parameters and the steering parameters, we've given them the baseline for where we require segments on the knuckle to be produced. And the knuckle is one of the key members that's required for the vehicle to connect to the tires, which is the only contact with the ground. In terms of next steps, as I answered Akash's question earlier about optimization of the chassis. So the key components that we're missing, as Isaac mentioned, is the weights. We did make estimations and we came up with values such as a -2 degree camber, a 0 degree kingpin angle for now. However, this is modifiable because we're using tie rods which have threads on them. So these allow for extension or removal. And this modification, so the material cost for this was roughly around $40. So it's a really cheap part to replace and change the lens for. And the turnaround time for it is about 3 days from Metal Supermarkets, one of our sponsors. Specifically, the next stages for the FSA teams and any other future capstone would be the, as Isaac mentioned, tuning of the suspension specifically for the weights, including rebound and maybe even changing out springs. Right now, based on the weight we estimated, which I believe was 300 kilograms total weight, or 300 pounds total weight, we are probably going to be much higher. The chassis weight itself is pretty high, and there's likely optimization available for changing the tube diameters of the chassis, as well as changing out sections of triangulation and bent members. In terms of manufacturing, as it was mentioned, none of us are welders. So we do need to get our drawings and our packages checked by experienced welders. We have made contact with one to do just that once everything is open again, to ensure that our models make sense, the parameters that we've chosen make sense, and the material makes sense.
Okay, thank you. So it sounds like welding was one of the pinch points, the bottlenecks. Something
we also have to, or we were attempting to keep costs down to manufacture everything in the Bergeron shop. So we were also limited by our tube bend angles and things like that.
Mm-hmm. Okay. Limitations are always an important factor in engineering design, and be open about that. Thank you. And with that, thank you all of the students for your presentation, for your answers to the questions, and well done on your projects. Give yourselves a hand. That was fantastic. That was the last of the panel sessions. Good job, everyone. Well done. You've done a fantastic job under constraints that most of the rest of us had never imagined we would, sort of encountered as students. So in spite of those issues, you've done superbly well. And beyond that, the projects were fantastic to begin with. So thank you. We're now going into looks like a 45-minute session for lunch. So stretch those legs, get some fresh air if you can. And then there's
a couple of notices as well, if I can jump in.
Absolutely.
Yeah, so Ramadan Mubarak for anybody who's fasting at the minute. And as James said, now is the break for lunch. Just to let you know, during lunch, we will be showing on loop a selection of the reflection videos that you were all shared with us. We unfortunately couldn't get all of you, so we apologize if you're not included. It was we take full blame for that. We just had to pick the ones that we could gather together that fit in a loop. But those will be playing during lunch on this channel if you're interested in looking at those. Also, we have an announcement that we'll make again after lunch about the NESI survey. Now's a good time to fill in the NESI survey if you haven't done yet. In the fourth year NESI completion, we're relatively low. So if those of you who are, haven't yet filled in the NESI survey could take the time, we will post the link in the Zoom chat to everybody. If somebody could just redo that, it was posted there earlier on. You may not be able to copy paste from there, but if you could go to that, that would be great. And just to let you know, two other things. Judges, we'd like to meet in our off main screen meeting room once you're ready. We will have that room open. Obviously, people need to take a break now, but once you're ready, if you could come back and join that other room, we can start our deliberation hopefully before 2 o'clock if we're ready. And one final thing, I have sent out an email through Moodle to everybody in the capstone teams about something that we're kicking off next year that we'll briefly talk about later on this afternoon. So keep an eye out for that. If there are no questions, then have a good break. And for those of you in the big room, we will see you back here at 2:30. The deliberation will happen offline, but the video will be playing during the break. for you to enjoy seeing each other's reflections on the air. So if Nick, you could cue that up, that would be great. And we will see you back in this room at 2:30.
So Capstone was definitely one of my favorite courses I've taken in university, and I'm actually kind of surprised at how much I learned through the whole thing. I feel really confident now in how to organize and rally a team behind an idea, and likewise rally behind someone else's idea too. It's really nice to now have like a more cohesive tool set and like how to organize a team in that sense.
All right, number one, if you are going to be the leader, be cognizant of other people, but also be confident in your decisions. Number two, people who are very intelligent may be great, but try to find people who have similar work ethic as you do, or have people that balance your work ethic or complement it.
Having a shortened timeline was the best thing we did closer to the end. We were always working, we were always motivated, and we always had goals that were right ahead of us. When we had the longer time gaps, oftentimes there was a lot of slacking.
If you don't like the people that you work with, then it's going to be a lot harder to get things done. And it always feels like team dynamic is very underrated, but like it is probably the most important thing, and I would have probably spent more time getting to know everybody right in the beginning of the year if we could understand each other right from the get-go.
Since September till now, I've learned a lot: how to communicate, how to learn, how to apply what you have learned, and time management. These 4 points help me out how to do a project. So any person have to make sure he or she has these 4 points in order to get the things done as soon as possible.
I learned a lot about the project structure, and it really surprised me the amount of paperwork that's required for even a simple project. Every step needs to be recorded. I'm pretty proud of the work that was done on the project, especially how far we've got to, even though we did have to reduce our scope.
When I get inspired by something, I just kind of want to execute immediately, and then it doesn't really work out well because it doesn't. You need to plan for things first. And then I get like disappointed and I just back away from it and basically quit. So yeah, I've learned that the process is actually more important than the actual final goal. And also that it doesn't take much for you to make someone feel excluded, and when someone does feel excluded in a group, like it only takes one person to get it done, and it can become hard for them to like participate as they would normally do. And I've learned that I should just focus on the end goal anyway, even if I'm in that kind of situation in the future, because in the end it's your work that's going to get it done, not you yourself. So.
Ask a lot of people for different ideas, because you might know one way, your entire discipline might know it one way, but other people might know it another way. Small details bite you in the butt, so you might not consider them right now, but make sure to have them in the back of your head and make sure to address it earlier and not later. And finally, manage your team, manage time properly amongst yourself and everyone for equal share.
Plan ahead of all the planning. So double plan as much as possible and as early on as possible, so you don't end up submitting your project at 4 in the morning with sleep deprivation clearly visible. And also, from the very beginning of defining your project and knowing what your project is about and knowing who your supervisor is, sitting down with your supervisor and your group as early on as possible within the first few days of the year to identify the very key objectives of the project, so that you can ask yourself and your group members, how can we allocate the time, the resources, and each individual skills of the members to be able to meet the demand of the project within the allotted time limit of the 8 months, within the budget limit, and within the resources that we have access to from the campus and from external resources.
Don't underestimate how long the MVP will take, because it took us a really long time. No matter how much planning you do right now, everything's always going to change. Take advantage of the half-price nachos at the underground every Friday, and don't order 200 stickers right before pandemic, because then you're going to have nothing to stick them on.
Make your own choices. Throughout the course of a project, you're going to have many different external sources or external people give their opinions on how your project should be run. And it's great to have different opinions, but at the end of the day, it's your choice. And in fact, it should be up to the team members to decide on the direction the project should be run.
If I had the chance to go back to the beginning of the school year and tell myself some tips and advice for this capstone project, I would definitely start off with telling myself to be realistic. You're not working for NASA, you're not working for SpaceX, you're not trying to build a 100-meter rocket to take you to Mars or Jupiter. You just want to build maybe a 6 to 8 foot rocket, at least get it up into the atmosphere. Don't do maybe 15,000 kilonewtons, a couple kilonewtons, that's too big. Start with maybe 500 to 1,000 newtons. And with this, it's also understand the goal and work towards it. Stay within the project scope. And your team, they're here to help you. If you struggle with anything, if you encounter difficulties or are falling behind, talk to them. They'll help you, they'll guide you through it. You're all in this together and want to accomplish the same goal.
When you finish one report or one part of the course, you're not done. You don't get a break. It's not like another course where when you finish an assignment, you know, you might have like a gap of like a week or something until you have to start working on another assignment. No, when you submit that report, you need to start working on it right away. Our group didn't figure that out until 2/3, maybe 3/4 of the way through the course. I would just say get on it right away.
I think if I could go back, I would tell myself to focus on the problem. And initially we thought we were doing that, and it was always something that I've done in the previous projects. But I guess when presented with the idea behind our problem, or the intended idea, I was kind of focused on the solution that was kind of provided to us by the professor, or something that we quickly came up on the spot. And we spent a lot of time working towards that solution instead of working towards solving our problem, and I think that ended up wasting a little bit of our time. But overall, we ended up solving the problem instead of just picking a solution and going with it, and I think it turned out pretty successful. We could have just gotten there a little quicker, probably.
Just make sure that you schedule some time to work on the capstone project, and most importantly, work on it early, because you will run into bugs that takes hours to fix, and it's better to fix the bugs early rather than when it's crunch time, it's last minute.
And make sure that before you pick your projects you are passionate about, because you're going to be working on it for the whole year. And make sure that you have a good team and a good working environment with your team, like no conflicts. And whenever you have any problems, just go to your supervisor or your professor and leave the work of building the refrigeration cycle or anything that you cannot build physically to the professionals. That's why we're given a budget. We can just use it to have someone to build it for us.
So advice for me would be, do what you could at the time, don't overthink the design, and don't worry about it not being the best design, because this is a learning experience. So the second thing I wanted to bring up was to spend more time with group members. Don't force ourselves to meet up only a few times a month, because then the work becomes cluttered. So spread out meetings more thinly, that way we don't spend so much time on at once, and then so just in case myself or anyone else would forget anything. Overall, this was an interesting experience because it was a year-long project, and this class gave me a better understanding of project development. Thank you.
So Capstone was definitely one of my favorite courses I've taken in university, and I'm actually kind of surprised at how much I learned through the whole thing. I feel really confident now in how to organize and rally a team behind an idea, and likewise rally behind someone else's idea too. It's really nice to now have like a more cohesive tool set and like how to organize a team in that sense.
All right, number one, if you are going to be the leader, be cognizant of other people, but also be confident in your decisions. Number two, people who are very intelligent may be great, but try to find people who have similar work ethic as you do, or have people that balance your work ethic or complement it.
Having a shortened timeline was the best thing we did closer to the end. We were always working, we were always motivated, we always had goals that were right ahead of us. When we had the longer time gaps, oftentimes there was a lot of slacking.
If you don't like the people that you work with, then it's going to be a lot harder to get things done. And it always feels like team dynamic is very underrated, but like it is probably the most important thing, and I would have probably spent more time getting to know everybody right in the beginning of the year if we could understand each other right from the get-go.
Since September till now, I've learned a lot: how to communicate, how to learn, how to apply what you have learned, and time management. These 4 points help me out how to do a project. So any person have to make sure he or she has these 4 points in order to get the things done as soon as possible.
I learned a lot about the project structure, and it really surprised me the amount of paperwork that's required for even a simple project. Every step needs to be recorded. I'm pretty proud of the work that was done on the project, especially how far we've got to, even though we did have to reduce our scope.
When I get inspired by something, I just kind of want to execute immediately, and then it doesn't really work out well because it doesn't. You need to plan for things first. And then I get disappointed and I just back away from it and basically quit. So yeah, I've learned that the process is actually more important than the actual final goal. And also that it doesn't take much for you to make someone feel excluded. And when someone does feel excluded in a group, it only takes one person to get it done, and it can become hard for them to participate as they would normally do. And I've learned that I should just focus on the end goal anyway, even if I'm in that kind of situation in the future, because in the end, it's your work that's going to get judged, not you yourself. So.
Ask a lot of people for different ideas, because you might know one way, your entire discipline might know it one way, but other people might know it another way. Small details bite you in the butt, so you might not consider them right now, but make sure to have them in the back of your head and make sure to address it earlier and not later. And finally, manage your team, manage time properly amongst yourself and everyone for equal share.
Plan ahead of all the planning. So double plan as much as possible and as early on as possible so you don't end up submitting your project at 4 a.m. with sleep deprivation clearly visible. And also, from the very beginning of defining your project and knowing what your project is about and knowing who your supervisor is, sitting down with your supervisor and your group as early on as possible within the first few days of the year to identify the very key objectives of the project so that you can ask yourself and your group members, how can we allocate the time, the resources, and each individual skills of the members to be able to meet the demand of the project within the allotted time limit of the 8 months, within the budget limit, and within the resources that we have access to from the campus and from external resources.
Don't underestimate how long the MVP will take, because it took us a really long time. No matter how much planning you do right now, everything's always going to change. Take advantage of the half-price nachos at the underground every Friday, and don't order 200 stickers right before pandemic, because then you're going to have nothing to stick them on.
Make your own choices. Throughout the course of a project, you're going to have many different external sources or external people give their opinions on how your project should be run. And it's great to have different opinions, but at the end of the day, it's your choice. And in fact, it should be up to the team members to decide on the direction the project should be run.
If I had the chance to go back to the beginning of the school year and tell myself some tips and advice for this capstone project, I would definitely start off with telling myself to be realistic. You're not working for NASA, you're not working for SpaceX, you're not trying to build a 100-meter rocket to take you to Mars or Jupiter. You just want to build maybe a 6 to 8 foot rocket, at least get it up into the atmosphere. Don't do maybe 15,000 kilonewtons, a couple kilonewtons, that's too big. Start with maybe 500 to 1,000 newtons. And with this, it's also understand the goal and work towards it. Stay within the project scope. And your team, they're here to help you. If you struggle with anything, if you encounter difficulties or are falling behind, talk to them. They'll help you, they'll guide you through it. You're all in this together and want to accomplish the same goal.
When you finish one report or one part of the course, you're not done. You don't get a break. It's not like another course where when you finish an assignment, you might have like a gap of like a week or something until you have to start working on another assignment. No, when you submit that report, you need to start working on it right away. Our group didn't figure that out until 2/3, maybe 3/4 of the way through the course. I would just say get on it right away.
I think if I could go back, I would tell myself to focus on the problem. And initially we thought we were doing that, and it was always something that I've done in the previous projects. But I guess when presented with the idea behind our problem, or the intended idea, I was kind of focused on the solution that was kind of provided to us by the professor, or something that we quickly came up on the spot. And we spent a lot of time working towards that solution instead of working towards solving our problem, and I think that ended up wasting a little bit of our time. But overall, we ended up solving the problem instead of just picking a solution and going with it, and I think it turned out pretty successful. We could have just gotten there a little quicker, probably.
Just make sure that you schedule some time to work on the capstone project. And most importantly, work on it early, because you will run into bugs that takes hours to fix. And it's better to fix the bugs early rather than when it's crunch time, it's last minute.
And make sure that before you pick your projects you are passionate about, because you're going to be working on it for the whole year. And make sure that you have a good team and a good working environment with your team, like no conflicts. And whenever you have any problems, just go to your supervisor or your professor, and leave the work of building the refrigeration cycle or anything that you cannot build physically to the professionals. That's why we're given a budget. We can just use it to have someone to build it for us.
So advice for me would be, do what you could at the time, don't overthink the design, and don't worry about it not being the best design, because this is a learning experience. So the second thing I wanted to bring up was to spend more time with group members. Don't force ourselves to meet up only a few times a month, because then the work becomes cluttered. So spread out meetings more thinly. That way we don't spend so much time on at once, and then so just in case myself or anyone else would forget anything. Overall, this was an interesting experience because it was a year-long project, and this class gave me a better understanding of project development. Thank you.
Capstone was definitely one of my favorite courses I've taken in university, and I'm actually kind of surprised at how much I learned through the whole thing. I feel really confident now in how to organize and rally a team behind an idea, and likewise rally behind someone else's idea too. It's really nice to now have like a more cohesive tool set and like how to organize a team in that sense.
All right, number one, if you are going to be the leader, be cognizant of other people, but also be confident in your decisions. Number two, people who are very intelligent may be great, but try to find people who have similar work ethic as you do, or have people that balance your work ethic or complement it.
Having a shortened timeline was the best thing we did closer to the end. We were always working, we were always motivated, we always had goals that were right ahead of us. When we had the longer time gaps, oftentimes there was a lot of slacking.
If you don't like the people that you work with, then it's going to be a lot harder to get things done. And it always feels like team dynamic is very underrated, but like it is probably the most important thing, and I would have probably spent more time getting to know everybody right in the beginning of the year if we could understand each other right from the get-go.
Since September till now, I've learned a lot: how to communicate, how to learn, how to apply what you have learned, and time management. These 4 points help me out how to do a project. So any person have to make sure he or she has these 4 points in order to get the things done as soon as possible.
I learned a lot about the project structure, and it really surprised me the amount of paperwork that's required for even a simple project. Every step needs to be recorded. I'm pretty proud of the work that was done on the project, especially how far we've got to, even though we did have to reduce our scope.
When I get inspired by something, I just kind of want to execute immediately, and then it doesn't really work out well because it doesn't. You need to plan for things first. And then I get like disappointed and I just back away from it and basically quit. So yeah, I've learned that the process is actually more important than the actual final goal. And also that it doesn't take much for you to make someone feel excluded. And when someone does feel excluded in a group, like it only takes one person to get it done, and it can become hard for them to like participate as they would normally do. And I've learned that I should just focus on the end goal anyway, even if I'm in that kind of situation in the future, because in the end, it's your work that's going to get judged, not you yourself. So.
Ask a lot of people for different ideas, because you might know one way, your entire discipline might know it one way, but other people might know it another way. Small details bite you in the butt, so you might not consider them right now, but make sure to have them in the back of your head and make sure to address it earlier and not later. And finally, manage your team, manage time properly amongst yourself and everyone for equal share.
Plan ahead of all the planning. So double plan as much as possible and as early on as possible so you don't end up submitting your project at 4 in the morning with sleep deprivation clearly visible. And also, from the very beginning of defining your project and knowing what your project is about and knowing who your supervisor is, sitting down with your supervisor and your group as early on as possible within the first few days of the year to identify the very key objectives of the project so that you can ask yourself and your group members, how can we allocate the time, the resources, and each individual skills of the members to be able to meet the demand of the project within the allotted time limit of the 8 months, within the budget limit, and within the resources that we have access to from the campus and from external resources.
Don't underestimate how long the MVP will take, because it took us a really long time. No matter how much planning you do right now, everything's always going to change. Take advantage of the half-price nachos at the underground every Friday, and don't order 200 stickers right before pandemic, because then you're going to have nothing to stick them on.
Make your own choices. Throughout the course of a project, you're going to have many different external sources or external people give their opinions on how your project should be run. And it's great to have different opinions, but at the end of the day, it's your choice. And in fact, it should be up to the team members to decide on the direction the project should be run.
If I had the chance to go back to the beginning of the school year and tell myself some tips and advice for this capstone project, I would definitely start off with telling myself to be realistic. You're not working for NASA, you're not working for SpaceX, you're not trying to build a 100-meter rocket to take you to Mars or Jupiter. You just want to build maybe a 6 to 8 foot rocket, at least get it up into the atmosphere. Don't do maybe 15,000 kilonewtons, a couple kilonewtons, that's too big. Start with maybe 500 to 1,000 newtons. And with this, it's also understand the goal and work towards it. Stay within the project scope. And your team, they're here to help you. If you struggle with anything, if you encounter difficulties or are falling behind, talk to them. They'll help you, they'll guide you through it. You're all in this together and want to accomplish the same goal.
When you finish one report or one part of the course, you're not done. You don't get a break. It's not like another course where when you finish an assignment, you know, you might have like a gap of like a week or something until you have to start working on another assignment. No, when you submit that report, you need to start working on it right away. Our group didn't figure that out until 2/3, maybe 3/4 of the way through the course. I would just say get on it right away.
I think if I could go back, I would tell myself to focus on the problem. And initially we thought we were doing that, and it was always something that I've done in the previous projects. But I guess when presented with the idea behind our problem, or the intended idea, I was kind of focused on the solution that was kind of provided to us by the professor, or something that we quickly came up on the spot. And we spent a lot of time working towards that solution instead of working towards solving our problem, and I think that ended up wasting a little bit of our time. But overall, we ended up solving the problem instead of just picking a solution and going with it, and I think it turned out pretty successful. We could have just gotten there a little quicker, probably.
Just make sure that you schedule some time to work on the capstone project. And most importantly, work on it early, because you will run into bugs that takes hours to fix. And it's better to fix the bugs early rather than when it's crunch time, it's last minute.
And make sure that before you pick your projects you are passionate about, because you're going to be working on it for the whole year. And make sure that you have a good team and a good working environment with your team, like no conflicts. And whenever you have any problems, just go to your supervisor or your professor and leave the work of building the refrigeration cycle or anything that you cannot build physically to the professionals. That's why we're given a budget. We can just use it to have someone to build it for us.
So advice for me would be, do what you could at the time, don't overthink the design, and don't worry about it not being the best design, because this is a learning experience. So the second thing I wanted to bring up was to spend more time with group members. Don't force ourselves to meet up only a few times a month, because then the work becomes cluttered. So spread out meetings more thinly. That way we don't spend so much time on at once, and then so just in case myself or anyone else would forget anything. Overall, this was an interesting experience because it was a year-long project, and this class gave me a better understanding of project development. Thank you.
Capstone was definitely one of my favorite courses I've taken in university, and I'm actually kind of surprised at how much I learned through the whole thing. I feel really confident now in how to organize and rally a team behind an idea, and likewise rally behind someone else's idea too. It's really nice to now have like a more cohesive tool set and like how to organize a team in that sense.
All right, number one, if you are going to be the leader, be cognizant of other people, but also be confident in your decisions. Number two, people who are very intelligent may be great, but try to find people who have similar work ethic as you do, or have people that balance your work ethic or complement it.
Having a shortened timeline was the best thing we did closer to the end. We were always working, we were always motivated, we always had goals that were right ahead of us. When we had the longer time gaps, oftentimes there was a lot of slacking.
If you don't like the people that you work with, then it's going to be a lot harder to get things done. And it always feels like team dynamic is very underrated, but like it is probably the most important thing, and I would have probably spent more time getting to know everybody right in the beginning of the year if we could understand each other right from the get-go.
Since September till now, I've learned a lot: how to communicate, how to learn, how to apply what you have learned, and time management. These 4 points help me out how to do a project. So any person have to make sure he or she has these 4 points in order to get the things done as soon as possible.
I learned a lot about the project structure, and it really surprised me the amount of paperwork that's required for even a simple project. Every step needs to be recorded. I'm pretty proud of the work that was done on the project, especially how far we've got to, even though we did have to reduce our scope.
When I get inspired by something, I just kind of want to execute immediately, and then it doesn't really work out well because it doesn't. You need to plan for things first. And then I get like disappointed and I just back away from it and basically quit. So yeah, I've learned that the process is actually more important than the actual final goal. And also that it doesn't take much for you to make someone feel excluded. And when someone does feel excluded in a group, like it only takes one person to get it done, and it can become hard for them to like participate as they would normally do. And I've learned that I should just focus on the end goal anyway, even if I'm in that kind of situation in the future, because in the end, it's your work that's going to get judged, not you yourself. So.
Ask a lot of people for different ideas, because you might know one way, your entire discipline might know it one way, but other people might know it another way. Small details bite you in the butt, so you might not consider them right now, but make sure to have them in the back of your head and make sure to address it earlier and not later. And finally, manage your team, manage time properly amongst yourself and everyone for equal share.
Plan ahead of all the planning. So double plan as much as possible and as early on as possible so you don't end up submitting your project at 4 in the morning with sleep deprivation clearly visible. And also, from the very beginning of defining your project and knowing what your project is about and knowing who your supervisor is, sitting down with your supervisor and your group as early on as possible within the first few days of the year to identify the very key objectives of the project so that you can ask yourself and your group members, how can we allocate the time, the resources, and each individual skills of the members to be able to meet the demand of the project within the allotted time limit of the 8 months, within the budget limit, and within the resources that we have access to from the campus and from external resources.
Don't underestimate how long the MVP will take, because it took us a really long time. No matter how much planning you do right now, everything's always going to change. Take advantage of the half-price nachos at the underground every Friday, and don't order 200 stickers right before a pandemic, because then you're going to have nothing to stick them on.
Make your own choices. Throughout the course of a project, you're going to have many different external sources or external people give their opinions on how your project should be run. And it's great to have different opinions, but at the end of the day, it's your choice. And in fact, it should be up to the team members to decide on the direction the project should be run.
If I had the chance to go back to the beginning of the school year and tell myself some tips and advice for this capstone project, I would definitely start off with telling myself to be realistic. You're not working for NASA, you're not working for SpaceX, you're not trying to build a 100-meter rocket to take you to Mars or Jupiter. You just want to build maybe a 6 to 8 foot rocket, at least get it up into the atmosphere. Don't do maybe 15,000 kilonewtons, a couple kilonewtons, that's too big. Start with maybe 500 to 1,000 newtons. And with this, it's also understand the goal and work towards it. Stay within the project scope. And your team, they're here to help you. If you struggle with anything, if you encounter difficulties or are falling behind, talk to them. They'll help you, they'll guide you through it. You're all in this together and want to accomplish the same goal.
When you finish one report or one part of the course, you're not done. You don't get a break. It's not like another course where when you finish an assignment, you might have like a gap of like a week or something until you have to start working on another assignment. No, when you submit that report, you need to start working on it right away. Our group didn't figure that out until 2/3, maybe 3/4 of the way through the course. I would just say get on it right away.
I think if I could go back, I would tell myself to focus on the problem. And initially we thought we were doing that, and it was always something that I've done in the previous projects. But I guess when presented with the idea behind our problem, or the intended idea, I was kind of focused on the solution that was kind of provided to us by the professor, or something that we quickly came up on the spot. And we spent a lot of time working towards that solution instead of working towards solving our problem, and I think that ended up wasting a little bit of our time. But overall, we ended up solving the problem instead of just picking a solution and going with it, and I think it turned out pretty successful. We could have just gotten there a little quicker, probably.
Just make sure that you schedule some time to work on the capstone project. And most importantly, work on it early, because you will run into bugs that takes hours to fix. And it's better to fix the bugs early rather than when it's crunch time, it's last minute.
And make sure that before you pick your projects you are passionate about, because you're going to be working on it for the whole year. And make sure that you have a good team and a good working environment with your team, like no conflicts. And whenever you have any problems, just go to your supervisor or your professor, and leave the work of building the refrigeration cycle or anything that you cannot build physically to the professionals. That's why we're given a budget. We can just use it to have someone to build it for us.
So advice for me would be, do what you could at the time, don't overthink the design, and don't worry about it not being the best design, because this is a learning experience. So the second thing I wanted to bring up was to spend more time with group members. Don't force ourselves to meet up only a few times a month, because then the work becomes cluttered. So spread out meetings more thinly. That way we don't spend so much time on at once, and then so just in case myself or anyone else would forget anything. Overall, this was an interesting experience because it was a year-long project, and this class gave me a better understanding of project development. Thank you.
Hello, everybody. Hopefully we are back in. We are just moving our judges back into the big room. I don't know if Nick, you can move the camera around. So hopefully you can all hear me. Obviously, it's been a long day. We hugely appreciate everything you've done. Let me stop my camera and restart it, see if I can get my camera working. Give me 2 seconds just to fix my camera. I know what the problem is. There we go, and I will stop it here and restart it here. There we go, cool. We're in and off and running. So before we get into the main thing for this afternoon, there are obviously some announcements to be made and quite a few thanks to be made. So announcements, just to say, I really enjoyed watching the loop video over lunch. Thank you all for your reflections. Obviously, for those of you whose reflections we didn't share, apologies, we had to just pick ones that we could, and I think that was an excellent representation of all of you. Thanks as well for those of you who filled in the NESI student form. Please go and do it afterwards if you haven't. It makes a big difference to help us improve things going forward. You all in Capstone will have received an email, hopefully over lunch, announcing an opportunity kicking off next Friday, 2:30 in Zoom. If you haven't had enough of Capstone and want to carry on, it's purely voluntary. We're creating the opportunity for you to come together and work on projects that can help in your community with the COVID-19 issue, with social distancing challenges. We are looking for you as graduating Capstone students to lead these projects, those of you who have spare capacity, and we will happily have connect you to students from the rest of campus to support things as you get going. So we're inviting, in the first instance, Eng 4000, our cross-campus capstone, and another capstone in computer science to lead these particular groups. Again, though, this is a voluntary activity. Those of you who have bandwidth, we know that for some of you, just getting through the day is plenty of big enough challenge at the minute. You already have people to look after and the rest of it. And many of you are already engaged in many other ways. So this is not intended to take away from any of that. It's just an opportunity for those of you who find yourself with some extra time capacity and who are keen to build on what you've just finished in Capstone and try it out for a second time, but for real, to help in your communities. So that will be starting Friday coming. So to today. First thing I want to do is acknowledge, obviously, all the work that's happened throughout the year. The students have been working really, really hard. And then with the challenges that came in with the COVID-19 situation, the degree to which teams have been able to come together and work really well has astounded all of us, I think. I also want to acknowledge the cross-campus capstone students in the room. We have 4 teams this year who were not only participating in Eng 4000, but we're trying out our new pilot cross-campus capstone, where we had students working from right across campus together on a project. So in particular for our Eng 4000 groups, we had the antimatter group, the solar floaties group, Loop.grow, and the Green Go teams who were working across campus, along with 7 other teams who didn't have engineering students in those teams. So thank you to those folks for coming on that journey with us. I want to thank our judges. So we had a wonderfully large team of judges this year. We had 2 recent graduates who were actually Patel Award winners last year, Farouk Wash, who's currently in OPEG, and Akash Uerman from Motion Concepts. So thank you for participating and sharing your experiences and wisdom. We have 2 participants from Nascent, Peter Marshall and Kathleen Liu, who joined us last year as judges as well, so we appreciate that. We have Rajiv Srivastava from Namar Limited and one of the York PEO supervisors who pitched projects, who's been a partner with us for a while now, so we appreciate him coming back. We have Catherine, who, I can never pronounce your last name, apologies, Catherine, but I will attempt it, and apologies. Tuvatsidis, that's my best bet, and I'm hugely apologize for that, from TD, but actually ex-alumnus from Space. And also thank you to Philip, who joined us early on, and that was great to see as well. Louis Tai, who comes from the PEO York chapter, who has been a long supporter of York Capstones, who provides one of the 2 awards that we provide today, and who provides the supervisory support for a lot of our teams. So huge thanks to the PEO York chapter and to Louis for engaging. Amy Gorkle, who you all know very well, our Assistant Dean of Students, who is always engaged in these things. So thanks very much, Amy. And then a huge shout out to our TAs for the course, Uday, Bindra, Roger Carrick, Lucas, Ryan, and Vidushi. I don't know where we'd be without you. We're always so lucky on this course to have the best TAs. So thank you all for continuing in that same vein. We really appreciate it. So that's the thanks to our judges. Next thing to do is to thank in particular our PEO York chapter and Patel Family Award providers for the 2 awards today. The Patel Family Award for the project with the best overall social impact, immediate social impact, and the PEO Award for the best overall project with commercial potential. You will hear a music lesson going on in the background shortly, which will hopefully be a little bit of entertainment. These things happen in social distancing. So my son is going to have a horn lesson. So in the continuing down the path of thanks, there's a huge shout out to the people behind the scenes. So an event like today was only possible because of huge numbers of people working magic behind the scenes. We have on the video side, we have Nick, Dan's team, Dan, who spent many hours getting your videos ready, getting the clips ready. Huge shout out to the whole of Dan's team for pulling together and running today's video really well. Gayatri and her team, without whom we would be completely lost, who've managed to handle the handoff between teams, who've run so many events this year for us. Lost my place. Also want to thank the inimitable Claudia. Huge shout out to Claudia. We would not be able to run Capstone without Claudia, and it's been a real pleasure working with her on this, and thank you ever so much for all the hard work that you've done. We want to thank Sandy and her group for making sure that we could actually run Zoom today, and all the hand holding through making this all happen, and catching the fact that at one point we had a hot mic on YouTube. So thanks for all that hard work. And also thanks to all the families who've let you all do this for the day, because we know it's not easy at the minute to sort of juggle all these things. So thank you to all your families for that. And finally, thanks to the students. Wow, you know, we know that you're brilliant, but you really did a wonderful job today, very professional, really polished. It was just such a pleasure to see what you could actually do today. So thank you all. I'm sure I've missed people. Apologies beforehand for having missed people. Is there anything else that maybe Hassam or James want to chime in with? I will take that as a no. So
it's a thank you, and thank you to Franz for helping to set this all up. Thank you.
Well, okay. So now we're on to the biggest part of the day, which is the announcement of the awards. And before we go to the awards, there are a couple of things to say. The first is you all did really well. We were really taken aback by the quality in the current circumstances. You always pull through, and this year you've done us all proud. So whoever gets the awards, you've all done really, really well. Okay. We're going to start with the Patel Family Award. This is the award for the team whose project has the most immediate social impact. And we want to announce an honorable mention, a runner-up, and then go with the overall winner. So the honorable mention is Team AE for their desalination project. I can't remember the title of your project, but it's got Brian in the title, for the fact that this is a project that we really need to think about as a society urgently, because this is something that's coming up as a major problem. Our runner-up in the Patel Family Award was Team AA for their stem cell project. And to announce the winner, unfortunately, we haven't got anybody from the Patel family able to be present, but Amy will announce the winner of the Patel Family Award. So over to Amy.
Thank you, Franz. This was not an easy decision. We spent a lot of time deliberating on both awards, but the winner of the Patel Family Award spent a lot of time focusing on the social impact of their project from inception through to the end of their project. They highlighted the UN Sustainable Development Goals, and was truly a multidisciplinary project as part of the Capstone cross-campus project. And so I'd like to congratulate Team F for the Solar Floaties project. So good job, congratulations.
Thank you, Amy. And just to let you know, the awards will be provided later on. There will be a slight delay in providing some of the awards just because of the current situation, but we will follow up with emails to let you know when things should be coming out to you and so on. So today is the announcement, but the award will follow up afterwards. Okay. So now we move on to the PEO award. This is for the overall best project and the one with the most commercial success. We have an honorable mention here to Team J, our Loop.grow team with the indoor garden project. And our runner-up was Team N with the human-powered bike that had a lot of interest from many of the judges who were very keen to maybe acquire one when you get yourself set up. So thank you to those teams. And to announce the winner of the PEO award, I'm going to open the floor to Louis Tai.
This winner for the PEO York project of the I almost want to say project of the year, but the capstone PO award. It did have a lot of discussion amongst judges, and I think one key aspect of uh, one key reason we choose this team to be the winner is because of the current situation we are in. And if you look at the background behind me, can anybody guess what that means? That means engineers are here to change the world. That's what that's the design to change the world, right? So I think taking that into consideration, I'd like to congratulate Team AA for the stem cell-based drug discovery project. It was very well done. It's the right time to have that. So we truly believe this is the chance to for our engineering graduates to produce something that's going to change the world. Congrats.
Thank you, Louis. And thank you to all the teams. It's been a long day. We appreciate all your efforts. We appreciate the fact it's been a long year and you've worked really hard. And that's it for today's events. Are there any final announcements? In which case, thank you all for coming. Thanks for a very successful day. And we will hopefully see you online soon and in person in the not too distant future.
Okay.